If you have already joined the prelims advanced batch. Okay. Right. So see, I mean, the general structure of the class that we are going to follow here is that we would be having around 2.5 hours of the class, as is done in most of the institutes. At least I am not going to dictate a lot of it. Okay. I mean, perhaps maybe for 10 to 15 minutes is what the dictation is going to be. I do not believe in dictation for two reasons. One, I think that conceptual clarity is more important, and also there is ample material which is available in the market. We have already given you these notes. These notes have been prepared after a lot of effort and research and so on and so forth, and therefore I do not think that one needs to be dictated notes. So therefore, please do not expect that I am going to dictate you any notes. One is that. Second is that from the next class for geography, please do get an atlas. There are two atlases which are available in the market. One is the Oxford India Atlas and the Oxford Atlas for India. And then there is a Orient Black Swan Atlas which is there for the world. So I'll be getting one. I've just requested a copy. So what I told in the open session yesterday also, and just to reiterate some of you who might not have attended it earlier or yesterday, that okay, yeah, so the atlas is here. Yeah, thank you. This comes with a CD also which has some interactive quizzes and maps and all that. So I mean, yes, talking about the atlas, what I said was that, what I was about to say was that these atlases are going to be the linchpin of your preparation for geography, whether it is prelims or mains, and your preparation would revolve around these two atlases. So therefore, do make sure that you get your hand onto these atlases, irrespective of whether you are going to attend or join the classes here or not. This is a sincere request, because there are two reasons to that. One is that UPSC in recent times has started to ask a number of questions directly from the map, a trend which they had discontinued in 2012 and 13, but they have again revamped it in 2014-15. Another point is that if you have a good grasp of the map of the world and map of India in terms of where are what physical features, what is the kind of climate which exists in a certain place, what is the kind of vegetation which is there, the kind of soil, you would be able to relate it to the socio-economic life much better. For example, one very simple example is that the Thar desert of India, you would have seen people wearing these turbans. Now, the reason why these people wear turbans is because they want to protect their body and their head from getting dehydrated, and because there are these hot winds which blow during the day in these desert areas. Or say, for example, why is rice or the seafood consumption maximum in Japan? Right? Or why is a large percentage of it a seafood? It is again related to geography. So these are very simple observations, but they would go a long way in you trying to interrelate topics with each other, and this would not only be useful in, say, paper 1 in mains, but also in paper 2 and 3 at places. For example, security. Now, if you would see the areas which witness Naxalism in India, there is a peculiarity about those areas, that there are thick, deep forests out there. You have extensive mines available in those regions. So there is a relationship between geography and the socio-economic life and the kind of culture which has evolved in those areas. So therefore, do make sure that you have access to these two maps, to the atlases. Yes. Okay, so from the next class, what we'll also do is, that we'll take up one particular area of the world, say North Africa or the South Asia or something like that, and we'll study some of the physical features. I am not going to again tell you कि अच्छा यहाँ पर ये है, यहाँ पर ये है. I would rather want you to observe them, and we could discuss that, okay, this particular feature has evolved because of this particular geographic reason or endogenetic forces, and it has now acquired this shape or this landform or this form because of this process of the exogenic forces, right? So as far as the topics for today are concerned, we would be talking about the heat balance, the heat budget of the earth. We'll be talking about the factors which affect the climate. And then we would be moving towards the pressure belts of the earth, and what are the various winds, permanent winds as well as the local winds which blow on the surface of the earth, right? And post that, if we have time left, we would also be talking about jet streams, western disturbances, and yes, we will be also talking about the tropical cyclones. So these are the topics that we have selected for the first class, even though it might just seem out of order, but the reason why we did that was because this was supposed to be an open class also, and we wanted to just make it a little more interesting for the general audience, right? And these are topics which are a little difficult to understand as well from the perspective of a student. And once we are done with the class, we would be having a short 20-25 minutes test where we'll be giving you around 30 questions, and you could attempt them. And that will be a class assignment, and we'll be discussing some of the questions from that assignment, and then you will have a take home assignment also, right? Okay. Now first of all, talking about the heat balance and the heat budget. Okay. Now the amount of solar energy which is received by the earth is called as insolation. Now the surface of the earth, or earth as a planet, receives maximum of its energy, or in fact the only energy source from where it receives energy is the sun, and not all of the energy which is emitted by the sun reaches the surface of the earth. That 1 part of billion of amount or billion units of energy which is released by the sun and which reaches the earth is called as insolation, right? And the earth, the sun energy which reaches the earth is in the form of the short wave rays. So these are rays which are of short wavelength. So if you break down the composition of the energy which we receive from the sun, it can be divided into 3 parts. One is the white light, or the white rays, which is visible light to us, right? Then you have the infrared rays, and then the third one is the ultraviolet rays, right? So ultraviolet rays, as you all would be knowing, that there is an ozone layer which is present in the atmosphere of the earth, which is responsible for absorbing some of the ultraviolet rays, and therefore preventing us from contracting some kind of cancers and a large number of diseases, not only us but from for the animals as well as the plants, right? Now once the insolation is received from the earth, the question is that if we are only receiving insolation from the sun on the surface of the earth, if this insolation would not be radiated back into the space, the earth would perpetually go into a cycle of becoming a hotter and a hotter body, right? But such is not the case. And this phenomenon is explained by the concept of heat budget. Okay. So the heat budget is the condition where we are able to say very clearly that, as if I have to read out from your notes, I'll just read out the technical definition of how what it means by the heat budget. It says that the average temperature of the earth overall does not change in spite of continuous supply of the sun rays, right? And this is possible only when an equal amount of energy is sent back to the space by the earth system. And in a way, there is a balance between the incoming solar radiation and the outgoing terrestrial radiation, or the outgoing radiation which is reflected by the earth's atmosphere. And this is called as the heat budget. So let's assume that the sun, or the number of units that we are receiving from the sun in form of insolation, is 100, right? Now can someone tell me what happens to 100 units of this? इसमें से कितना reflect हो जाता है atmosphere से? How many units are reflected by the atmosphere? 30? 51? 51 is the energy, 51 is the unit which is absorbed by the earth's surface and which reaches the earth's surface. Okay. 45? 35? कितना लिखा है इसमें? मेरे को बताओ. 35 are reflected back to the space even before reaching the earth's surface, right? So this is scattered in the space only, and it does not reach the earth's surface. So we have these 35 units out of the 100 units which are reaching the earth from the sun, the 100 units of insolation, 35 of them is reflected back before it even reaches the Earth's surface, right? Then you have these 14 units of insolation which is absorbed by the layer of the atmosphere as well as the water vapor and the clouds which are present in the atmosphere of the Earth, right? And then you have these 51 units of energy which are absorbed by the surface of the Earth, right? Now this 51 units of energy is also radiated back into the atmosphere through a process called as terrestrial radiation, right? This process is called as terrestrial radiation, and the rays or the waves which are emitted are long length or the short wave. They are long, right? So these are waves, these are the rays which possess long wavelength, right? So this is just one simple fact which you need to understand as far as the budget of or the heat budget of the Earth is concerned. Apart from that, there are certain other minuscule parts of it, that what happens to this 14, 2 is absorbed by the water vapor and by the carbon dioxide, then some other units are absorbed by the clouds and they are reflected back and so on and so forth. There is no need for you to go into detail as far as prelims is concerned. Just understand that out of the 100 units of energy which is being received by the Earth's surface, or which is being sent or which is reaching the Earth's surface, around 35 of it gets reflected back by the space elements only and gets scattered. 51 of it reaches the Earth's surface and then it is also reflected back into the space through the terrestrial radiation, and 14 units of it is absorbed by the clouds, by the atmosphere, by the water vapor, carbon dioxide, which is also reflected back into the space, and therefore it helps maintaining the temperature and the heat budget of the Earth, right? So this is the simple concept as far as heat budget is concerned, right? Now what are the elements which influence the insolation which is received by the Earth? So one, as you all would know, is the revolution of Earth around the sun, right? So what happens is that the annual insolation which is received by the Earth during some particular point of time is slightly more than some other point. So you all would have heard of the perihelion and the aphelion. What do you mean by perihelion? Okay, the shortest distance which exists between the Earth and the Sun. So this is the time when we receive the maximum insolation from the Sun, and this in a way determines what is going to be the fact, or this is one of the factors which determines the insolation which is received by the Earth from the Sun, right? So during perihelion, the amount of insolation which is received is definitely more than when it is received during the aphelion, right? Okay. Second factor which influences the insolation which or the amount of insolation which is received by the Earth from the Sun is the rotation of the Earth on its own axis and the tilt of the Earth on its axis also. So as you all would know that the Earth is tilted at an angle of 23.5 degrees towards the Sun, and on top of that, Earth is a spherical body. So not all the parts of Earth receive the same amount of insolation. How? See this. Let's say this is Sun, right? And say this is Earth, tilted on its axis like this. Now some parts of the Earth would be receiving the sun rays directly. Yes, these parts of the Earth would be receiving the sun rays directly from the Sun, and there will be some parts of the Earth which would be receiving it at a slant angle. So when you will have a slant angle, the distance which would be covered, say in this case, or if I have to draw the Earth a bit bigger, okay. So in this case, the distance which would be taken for the sun rays to travel to the surface of the Earth would be significantly more when compared to reaching the tropics, right? And the area which would be covered by the sun rays between 23.5 and 23.5 north and south would be significantly lesser, right? इस area के अंदर जो आपकी sun rays receive होंगी, they would be more concentrated and they would be traveling shorter distances. Since they would be traveling shorter distances, it would mean that they would also be getting scattered less, and therefore the insolation which will be received between these areas would be more, and the insolation which will be received in these areas would be lesser, beyond the tropics would be lesser. This is clear to everyone? I see a few blank faces. If it's not clear, if anything is not clear, please tell me right now. Clear? Right? Okay. Then another factor which influences the insolation which is received by the earth is the length of the day. The longer the day, obviously the more would be the insolation which would be received by the earth's surface, and therefore the shorter the nights the longer the days, it would ensure that more insolation is received. Then the transparency of the atmosphere also plays a very important role in the amount of insolation which is received by the earth's surface. How? If you have a cloudy day, what would be the effect on the insolation which would be received by the surface of the earth? It would be lesser, right? But if it's a cloudy day, what would happen to the temperature of the earth? It would be more or less? Why? Okay, so because of the greenhouse effect of the clouds, they would not allow the terrestrial radiation to be radiated back into the space very easily. And the energy, you have to understand, the Earth's atmosphere actually gets heated up more because of terrestrial radiation when compared to the amount of energy which is received from the sun directly. So जो insolation से heat आती है और जो terrestrial radiation से heat निकलती है, terrestrial radiation heats up the earth's surface much more than the insolation from the sun, right? And because of that fact, if there is a cloud cover which is present on a particular given day, what would happen is the temperature of the earth's surface would be significantly more, right? The reason for that is because terrestrial radiation ज़्यादा heat up करता है compared to insolation. There is no doubt if there is cloud cover present, insolation coming would also be less. But at the same time, since terrestrial radiation would not get escaped, yes.
So, but the rays coming are less too, right?
Sorry, the rays coming.
Is that coming to atmosphere
Yes, that's what I'm saying.
also less?
Yes, exactly. So that's why I said, see, what is happening is when you talk about the insolation which is received, the insolation would be definitely reduced, right? But which one has greater effect in heating up the earth? Is it the insolation or is it the terrestrial radiation, right? Since terrestrial radiation is more effective in heating up the atmosphere and heating up the earth's surface, what tends to happen is that even if we decrease the insolation coming, the terrestrial radiation's effect would be enhanced in comparison to the insolation getting reduced. And therefore, the earth's surface and the earth's atmosphere would get heated up more on a cloudy day, right? So there could be a question in prelims which could be put up like that: you have a cloudy day and a particular condition would be given to you, and in which of the following condition would the average temperature which would be witnessed on the earth would be more on a cloudy day with or on a day with clear skies, or on a day with clear skies and something, and they might just give you options like that, right? Similarly, they might give you a very simple question related to what are the factors which affect the insolation which is received by the earth's surface, right? So they have been giving these questions, and what they will do is that they will give you like 6 or 7 options, like not A, B, C, D, E, F, but 1, 2, 3, 4, 5, 6, 7, and then the options would be A, 1, 2 and 3, B, 1, 2, 3, 4, 5, C, 1, 2, 3, 4, and so on and so forth, right? So this is as far as the insolation and the heat budget of the earth is concerned, right? Now let's move on to something which is more relevant, and these are very trivial topics, but I just wanted to touch upon them just so that people, those who are just starting out or those who do not have a lot of background in geography. Yes.
If there is no cloud, then the earth temperature will be less as compared to cloud.
Yes. Yes. On a cloudy day, the temperature of the earth would be more when compared to a cloudless day, right? Okay, fine. See, I'll give you an example for that. When you talk about the deserts, right? Desert areas, if you see, they have usually clear skies. Now, what happens in the deserts is that during the day, the temperature is really high, right? But during the nights, the temperature goes down significantly. The reason for that is that there is no cloud cover which is present. But also do remember that when I am talking about the temperature of the earth, I am talking about temperature of, or this is not the temperature of the earth as such, but temperature of a particular place which I am talking about. and this would be the average temperature of that place would be significantly higher if it's a cloudy day, or if there are clouds which are present. But if you look at the day and the night, it would be different. So if it's day, the temperature would be lesser if it's a cloudy day, but in the night the temperature would be significantly more, and the average of this would mean that the temperature on a general basis would be more than on a cloudless day, right? In the same way, when we talk about the deserts, what happens in the deserts is that you have clear skies throughout the day and during the night also, and therefore when you will go to the desert, you will realize that there is a certain drop in temperature during the nights, and the diurnal range of temperature, I hope you all understand, right? Diurnal pata hai? Nahi? Can someone explain diurnal? What is diurnal range of temperature? Between the maximum and the minimum in the day is the diurnal range of temperature, right? And then what is the annual range of temperature? Right, the maximum and the minimum, right? And similarly, you would have a monthly range of temperature and mean and so on and so forth. There are a lot of terms which are there. You could read through them through your notes as well as the standard textbooks. So as far as the diurnal range of temperature is concerned, the deserts, the diurnal range of temperature would be significantly more because of the absence of this cloud cover, right? Okay. Now, talking about something which is called as, yes.
But then you said that the temperature drops down during night in deserts. And what's the reason behind that?
The reason behind that is because you have clear skies, and therefore the heat which is lost due to terrestrial radiation is significantly more. If you would have had clouds, the clouds would have trapped the heat, or if you would have water vapor or some other elements which have been present, which is not present in the desert area because there are completely clear skies, humidity is almost is very suspended particles are there. I mean, who's denying that? There will be heat which will be trapped, but I am talking of, see, it's all relative. Talk of, say, comparing, let's say, place like Mumbai to a place in the Thar desert somewhere in Jaisalmer, right? So that place would not be having any cloud cover, and therefore the heat which will be lost due to terrestrial radiation would be significantly more, right? Clear to everyone? Yes. Sorry? So, okay, so sunspots and the magnetic flares, etc., we'll talk about them in the later classes. Today we are just specifically restricting us. So sunspot, I'll talk about the sunspot activity, magnetic flares and the solar. No, we'll talk about it in the next classes, right? Okay. Yes. Sorry? No, terrestrial radiation takes place during the entire day, but it is significantly more during the night because the insolation received is zero during the day, and therefore the process of terrestrial radiation fastens up or accelerates in comparison to the insolation during the night, right? So terrestrial radiation takes place during the entire day, but during the night the process of terrestrial radiation accelerates, right? Okay, fine. Now talking about the heat balance of the earth, see, what tends to also happen, as I said, is that the earth is tilted at a 23.5 degree, and because of that some parts of the earth receive more insolation. They receive it not only more in quantity, but also that is concentrated over a particular area. If such would have been the case, what would have been happening is that the tropics would have been becoming more and more hotter, and the temperate latitudes and the higher latitudes would have been becoming much and more and more cooler. But such is not the case as far as earth is concerned. And this equilibrium which exists between the tropics and between the higher latitudes is something which is called as the heat balance of the earth. There is a balance which is maintained on the surface of the earth because of various forces which are acting, which allows that the heat between the tropics and between the higher latitudes gets distributed, right? Okay, how does that happen? First of all, let's talk about something important. The surface of the earth had been divided into 3 zones by the Greek scholars. Okay. They called the zone between 23.5 north and 23.5 south as the torrid zone. these zones, as per the Greek scholars, many years back, when they gave this theory or they gave this hypothesis, they said that these zones are torrid zones which receive the maximum insolation. They receive it at a direct incidence of the sun. There is no angle which is there, right? Otherwise, when if this is the sun, and as I said, some of the parts of the earth would be receiving it at some angle, right? Agar ye ek plane hai, so some of the parts of the earth would be receiving the rays of the sun at an angle, whereas between 23.5 south and 23.5 north, the sun rays are incident directly upon the surface of the earth, and therefore they are traveling the shortest distance, right? They are traveling the shortest distance, and at the same time they are concentrated over a smaller area, and these regions are generally regions of higher temperature compared to the other regions on the map of the earth, right? Then they talked about something called as the temperate zone. So the temperate zone, as per them, was 66.5 degrees south and 66.5 degree north. So these two zones between 66.5 degree north and 23.5 degree north, and same in the southern hemisphere, are called as the temperate zones, right? These are the zones where they say that the amount of insolation which is received by the earth's surface is significantly lesser than what is received in the torrid zone. One is that. And when you talk about the third zone, these are called as the frigid zones, right? These are frigid zones. They exist beyond the Arctic Circle and the Antarctic Circle, right? So these till 90 degree south and 90 degree north are the zones which receive almost no insolation in terms of amount of insolation. The reason for that is that the distance which the sun rays have to travel is significantly more, and they are incident on an oblique angle, and because of that they get heated up lesser, right? Also, one thing about these frigid zones is that during the summers these frigid zones experience daylight up to almost 20 to 24 hours. Yeah, come in. During the day, during the summers, these frigid zones experience the daylight almost 20 to 24 hours. Can someone tell me why? Yes, exactly. So because of the tilt of the earth, this part of the earth, for example, during the summers, so this in the northern hemisphere, when we will be having the summers, this particular part would be having the incidence of all the energy and all the insolation, and this would be lighted up, right? Do you want me to explain it with the help of certain models, or is it clear, right? So, and then there is the part which is below 66.5 degrees south, which will not be receiving any insolation at all, which will not be receiving any sunlight, and there will be a perpetual state of darkness which these areas would be witnessing for a certain period of time when the northern hemisphere is witnessing the summers, right? So out of 6 months, 3 months, these particular areas would be in complete darkness. And similarly, on the opposite hand, in the northern hemisphere during the summers, out of 3 months out of the 6 months, we will be seeing that there will be perpetual light which will be available in these areas, right? So you will be having a day which will be as long as 20 to 24 hours. But in spite of that, that does not necessarily mean that the temperature of these areas would go up, for a simple reason that the insolation which is being received is significantly lesser per unit area when you compare it to the insolation which is received in the temperate and the torrid zones, right? Okay. Now, so when we talk about the heat balance of the earth, okay. So as I said that in spite of the received insolation, there is a balance that is maintained worldwide, right? And as the low latitude areas receive more radiation, then they lose, and the high latitude areas receive lesser radiation than they receive, right? You get the point? So when I talk about the low latitude areas, they receive more radiation than they actually lose. टेरेस्ट्रियल रेडिएशन का जो रेट है यहाँ पर सिग्निफिकेंटली कम होता है. सो द lower latitude areas, that is between the 23.5 degree north and the 23.5 degree south, receive more radiation and lose lesser radiation, and therefore they have higher temperature. And when you compare them with the higher latitudes, what tends to happen is that the radiation which they receive is lesser compared to the amount of radiation which is lost by them, and therefore they are cooler places, right? But at the same time, there are certain forces which are acting on the surface of the earth which help us maintain this heat balance. What are they? First of all is the presence, it's because of the movement of the air masses and the ocean currents. Now what tends to happen is, as you all would know, which particular body gets heated up more quickly, land or water? Land. Why does water not get heated up as quickly as land? Tell me in a more layman term.
It is moving and then it is transparent in the layers.
Okay, yes. So what happens as far as the water is concerned is that the water has got deeper layers and it has got transparent characteristic, right? Now because of those transparent, or if you will call it oplucent characteristic, what tends to happen is that the rays of the sun tend to go deeper into the layers of the oceans, and even the top layers of the oceans, which get heated up significantly more than the deeper layers, keep mixing up with the bottom layers which are much cooler. The same is not the case as far as the land is concerned. So specific heat capacity is obviously the technical explanation of that thing, that the specific heat capacity of land is more, that for per unit energy which is received by the land, it gets heated up more when compared to water, right? Now what tends to happen is, in spite of all of that, the water in the equatorial regions is warmer when compared to water in the temperate or the higher latitudes, and therefore in the form of the ocean currents we witness movement of ocean water from the hotter areas to colder areas, or colder areas to hotter areas. How does water move? Higher pressure कहाँ होगा? Yes, right. So therefore you will be witnessing movement of the ocean currents from the higher latitudes towards the lower latitudes, right? And therefore this would help maintain a balance of temperature between the lower and the higher latitudes. But at the same time, you have ocean currents moving from the lower to the higher latitudes as well, as you would have heard of something called as the North Atlantic drift, right? So what happens because of North Atlantic drift is, if I'll show you the map of the world. Okay. Now this North Atlantic drift, there are certain ports here in the country, in Norway. Okay. They remain open throughout the year because of the presence of North Atlantic drift. North Atlantic drift is a current which is warm and it keeps the port open throughout the year in spite of that port lying above 66.5 degree north, right? This should have been a region where you should have witnessed icebergs and ice caps and so on and so forth, and what would have happened is that the ports would not have been opened. It would not have been safe to ship. The ships would not have been able to move. But because of the presence of North Atlantic drift, which is a warm current, these ports remain open throughout the year. But at the same time, when you compare it to the ports in the northeastern part of Canada here, right? This is northeastern Canada. In the northeastern part of Canada, we witness that shipping does not take place during the winters. The reason for that is that there is a presence of a cold current called as the Labrador current, right? There is a presence of cold current which is the Labrador current, which does not allow the melting of the ice and therefore does not allow clear shipping lanes for shipping and for the related industry, right? Fine. Similarly, what you also have is that once the hotter areas get heated up, there are winds which blow out from these hotter areas towards the is that the way it is? Okay. So it's not necessarily just that the winds blow out from the hotter areas to the colder areas and so on and so forth. It's basically because of the pressure, right? So I'll just talk about that pressure element. Before that, I'll talk about what are the factors which affect the climate of a place, right? First of all is the latitude. How does the latitude of a place affect the climate? Yes. So again, simple, right? Insolation which is received by some parts of the earth is more. And as I said, that areas that will be lying between 23.5 degree north and 23.5 degree south will be receiving more insolation. And there will be there will be straight incidence of the sun on these areas. And therefore, the amount of heat which is generated in these areas would be more, and therefore would be affecting the climate of these regions, right? One is that. Second, altitude. Can someone explain to me how altitude affects the climate of a place? The higher we go, the temperature will lower down. Can someone give me an explanation for this? Raring of the air. Okay, one reason. Then what else? Okay, yes. So as I told you that it is the terrestrial radiation which heats up the atmosphere more than the insolation, right? Now, therefore, the lower you are, the more heated up would be the air near the lower layers. One is that. Second, as she also said, that the density of the air as you go up is significantly lesser, right? You have lesser water vapor present, lesser carbon dioxide and other gases which are present, which can trap the heat. Whereas in the lower layers, you have the density is significantly more. You have more water vapor, you have more carbon dioxide, which can trap the heat and therefore increase the temperature of that particular place. Yes. Okay. So I was coming to that. So as far as when you move from the lower altitude to the higher altitude, what happens is that there is a decrease in temperature which takes place at the rate of 6 degrees Celsius per 1 kilometer, right, or 1000 meters, and that is called as the normal lapse rate. But this normal lapse rate differs from place to place. This is the normal average lapse rate which is witnessed, but this differs from place to place is one. Second is that the lapse rate is more during the summers than in the winters, right? And this is one of the reasons why people actually go to hill stations during the summers, because the temperature in the hills is significantly lesser compared to the temperature in the plains. Clear? Right? There are certain concepts called as the environmental lapse rate and the wet adiabatic lapse rate and the dry adiabatic rate and all those things. We'll talk about them when we talk about the concept of humidity, precipitation, convection, rainfall and all those kind of things. We'll talk about them in the later classes. But for now, just understand that the rate at which the temperature decreases when we go up the altitude is called as the normal lapse rate. Right? Now, there is something called as temperature inversion also which happens. Normally, as we move up in the atmosphere, the temperature should decrease, but it is witnessed at in some places the temperature increases as we move up the atmosphere as we move higher into the altitudes, right? One of the very classic examples of that is the valleys of the mountains, right? So what tends to happen in the valleys of the mountains is that during the day the valleys get heated up significantly lesser than the slopes of the mountains, right? Because the sun rays are not able to penetrate deep into the valleys, right? Now, what tends to also happen is that during the night in these mountains, the amount of heat which is lost by the upper slopes is significantly more when compared to the valley regions. And because of that, the temperature in the there is high pressure which is developed on the slopes, the higher slopes of the mountains when compared to the valley regions. And there is a movement of winds which takes place during the nights from the higher slopes of the mountains to the valley regions, and it leads to temperature inversion because there is a sudden drop which is witnessed in the temperature of the valley regions compared to the higher slopes during the night. And as one would move up because of these winds, the temperature in the mountains would go on increasing rather than decreasing. This is what is called as temperature inversion. Now, there are certain socio-economic effects of temperature inversion. For example, what tends to happen in the case of temperature inversion? Okay, so see, right, this is valley and these are your higher slopes. ठीक है. Now what tends to happen during the night is that these slopes tend to get they tend to cool up much more quickly than the valley regions. They lose more heat than the valley regions, right? And what happens is that you have high pressure which is developed in these regions. The winds blow down the slope of the mountains from the high pressure to the low pressure regions, and there is accumulation of these cold winds out here, right? They bring cold winds blow from the slopes to the valleys. And what tends to happen because of this is that the temperature which is there in the valley is significantly lesser when compared to the temperature in the slopes. And therefore, as you move up the mountains, you will realize that instead of the temperature going down, the temperature is actually going up. And that is called as temperature inversion. There are various socio-economic effects of this. At times what tends to happen is that a large number of orchards and the plantations, etc., which are there in the valley tend to get destroyed during the nights because of these winds which blow during the night, right? Because of the process of temperature inversion, right? Also, another example of temperature inversion is witnessed in the tropics. How does that happen? दे दो एक और. नहीं ये okay, fine. So I'll talk about that but little later because we are running a little short of time. So okay, so as far as this particular, so there are two factors which we have talked about till now, the latitude and the altitude, right? Okay. Then the continentality of a particular place also determines the climate of that particular place. For example, you would have witnessed that the temperatures in the city of Delhi are extreme or more extreme when compared to the temperatures which are witnessed in Mumbai or say in Chennai. What is the reason for that? Again, the simple reason is because of the continentality, and as I talked about the specific heat of the land, the land tends to get heated up more in the interior of the continents and therefore also tends to lose heat also at a much rapid pace when compared to the areas which are located near the sea, right? So continentality of a particular place also determines the temperature or the climate of that particular place, right? Now, the fourth reason which or the fourth factor which affects the climate of a particular place is the fourth okay, the fourth is the orientation of that particular place. Say for example in the case of the mountains, right? So as you would see that the southern slopes of the Himalayas which are towards India are relatively much more warmer. The temperature is much higher when compared to the northern slopes towards the China or towards Nepal, right? Similar is the case when we talk about the Alps, right? When you have mountains which are oriented in east-west direction, like this, the Himalayas are oriented in the east-west direction. So the northern slopes, this is the northern slopes and these are the southern slopes. The northern slopes of the Himalayas are significantly are experiencing more extreme climates when compared to the southern slopes, right? Also another factor which affects the climate of a particular place is the slope itself. Again, southern Himalayas, the slope is significantly much more steeper when compared to the northern Himalayas or the northern slope of the mountains. What tends to happen because of that is that the temperature or the climate which is experienced in the southern part of the Himalayas and southern slope of the Himalayas is significantly much more harsher when compared to the northern Himalayas. But the overall effect because of the insolation being received in lesser quantity on the northern Himalayas leads to the northern Himalayas having a much more harsher climate compared to the southern Himalayas. Right? This is clear? Yeah. Sorry? Okay. So see, what I'm just trying to say is that when you talk about the northern and the southern slope of Himalayas, the insolation is received directly on the southern slopes, right? And therefore the average temperature of the southern slope of the Himalayas is more than the northern slope of the Himalayas, right? But at the same time, the slope which is present in the southern part of the Himalayas is significantly more steeper than compared to the northern slope of the Himalayas. You would have also heard that the mountaineers actually do not climb Mount Everest from India's side, but they rather do it from Nepal's side, right? The reason for that is that the slope there is much more gradual, and here the slope is much more steeper. And because so what I was just trying to say was that the slope of a particular mountain or slope of a particular place also determines the climate of that particular place. The greater slope or the steeper the slope would be, the more harsher the temperature variations would be in that particular place. Whereas when you talk about the northern Himalayas, the temperature extremities would be significantly lesser. But as I said, because so that's the entire concept, right? And at the same time, you have to also keep in mind that the southern Himalayas receive more insolation than the northern Himalayas, and therefore the temperature overall remains to be much more in the southern Himalayas compared to the northern Himalayas, right? Clear? Okay. Now, okay, so this was, yes, the factors affecting the climate. This is in your material number 15, which has been given to you, right? So it says that factors which are affecting the climate, latitude is one which we have talked about, altitude is the second one. The third one is the continentality of a particular place or the distance from the sea. I gave you example of why Delhi has much more extreme climates as compared to the Mumbai, right? Then the ocean currents. Ocean currents also determine the climate of a particular place. Now, presence of warm ocean currents and the presence of cold ocean currents have significantly different effect on the climate of a particular place. When we talk about the cold ocean currents being present in a particular place, हमने अभी already Norwegian coast की बात की थी, and we compared it to the Labrador current which is present on the northeastern part of the Canada, right? That is one example. Another example is the coast of Peru, right? So you would have heard about what happens in the coast of Peru during the El Nino, etc., right? So usually there is a Peruvian cold current which is present at the coast of Peru. So if you look at the map of South America, this is Peru and Chile, right? So the coast of Peru and Chile have cold currents in normal conditions which are there, and because of these cold currents, the temperature or the environmental conditions remain to be stable, right? Remain to be stable का मतलब ये है that there is, since the temperature is lesser, there is no convection which is taking place. Since there is no convection which takes place, there is no precipitation which takes place. You get what I'm trying to say? Because of the presence of a cold current near the coast of Peru and Chile, there is a cold current which is flowing here by the name of Peruvian cold current. Okay. Now, since this current is cold in nature, there is no evaporation which takes place, right? Since there is no evaporation, there is no precipitation also, and generally this part of South America remains to be one of the driest places in the world. You would have heard of a place called as the Atacama Desert, which is the driest place in the world, which witnesses less than 10 centimeters of rainfall on an annual basis, right? But during some seasons, or not during some seasons, on a periodic basis, every 4, 5, 7 years, what tends to happen is that this cold Peruvian current is replaced by a warm current, right? And that condition is called as the El Nino. We'll talk about El Nino later in detail when we'll be talking about all the ocean currents. But for now, just understand that there is a cold current which is present on the coast of Peru and the coast of Chile, which leads to stable conditions, and therefore there are no rainfall which take place or no precipitation which takes place on this part of the world. Now, every 5 or 7 years, this cold current is replaced by warm currents, And what happens is, since the warm current has higher temperature, there is more convection which takes place, and therefore resulting in more precipitation. And suddenly Atacama Desert, which is one of the driest place in the world, receives heavy rainfall because of presence of warm current, right? So presence of warm or a cold current also determines the temperature of or the climate of a particular place. Clear? Right? Okay. Then you have the presence of local winds also. Now, what are local winds? See, as I said, there are, when we talk about winds, winds blow from areas of high pressure to low pressure. All of us know about it, right? There are certain local winds which are present in certain areas. Say, for example, loose during the summers in the northern part of India, or you have the winds by the name of Chinook, which are present in the Rockies, right? Or you have winds which are called as the Mistrals, or the Sirocco, or the Fawn, right? So, for example, the Chinook is called as the snow eater, right? What it does is that this is a wind. So, these are the Rockies on the western coast of the Americas, and what tends to happen is that the winds which ascend the mountains are cooler and they have moisture with them, right? But as they ascend the mountains, they shed all their moisture, and when they descend down the leeward side of the mountain, so this is the windward side of the mountain and this is the leeward side of the mountain, when they descend towards the leeward side of the mountain, they become hotter and they become drier in nature. And what tends to happen is that when they descend down the Rockies, they go into the Californian plains and into the region of California in North America, and they eat up the snow which is present there during the winters, and therefore these winds are also called as the snow eaters or the Chinooks, right? So the local winds which are also present in a particular place influence the climate of that particular region, right? This is clear. We'll be talking about local winds and the permanent winds as in just a while when we talk about the pressure belts and the other winds of the world, right? Then another factor which affects the temperature or the climate of a particular place is the natural vegetation in the soil, right? So if you would have seen in the desert areas, you have sands which are present in form of the soil. Now, sand as a soil is much more sensitive to temperature variations than the other soil. And this is one of the prominent reasons because of which you would also see the desert areas having significantly higher temperature during the day, because they have high specificity of heat. They tend to get heated very quickly as well as lose heat very quickly. And during the night, the desert areas would have significantly lesser temperature. One of the reasons for that is also because of the presence of the kind of soil which is there, right? Similarly, vegetation also plays a very important role. Any area which would have vegetation would ensure that at times the heat gets trapped. The heat or the terrestrial radiation gets trapped, and therefore places where you would have dense thick forest, the temperature of that particular area would be significantly much more compared to the nearby areas. But the same is also, if you look at it in a very with a very peculiar eye, there you notice something called as the urban heat islands. You would have heard of something called as the urban heat islands. So what tends to happen is that the temperature range which is witnessed in the areas, in the villages compared to the urban centers is significantly different. The reason for that is that in the rural areas or in the villages, what tends to happen is that you have water bodies which are present. There is a thick dense vegetation also which is present at point of times, and the evaporation and the terrestrial radiation is more, right? What tends to happen as far as the urban centers are concerned is there is no the drains are covered, the water bodies are absent, and because of that you have only concrete roads which are present. So these concrete roads tend to get heated up much more quickly, and the heat tends to get trapped in the concretized structures of these cities, and because of that the urban centers are witnessed to have 2 to 3 degree Celsius temperature on an average more than the surrounding rural areas, and therefore they become islands of heat called as the urban heat islands. Right? Clear? So this is also one aspect which affects the climate of a particular place. So urban climate is significantly different from the rural climate because of the kind of structures which have come up in the urban areas. You have all concrete structures, the drains are covered, therefore any heat which is absorbed by the water bodies in the rural areas is not absorbed here, and the concrete is the one which absorbs the heat and it traps the heat between the concretized structures. Right? So remember this particular thing also. Yes.
What is the role of greenhouse gases in the urban centers as compared to?
Again the same, because of the presence of the greenhouse gases and the larger quantity of greenhouse gases which is present in the urban areas, the heat tends to get trapped more compared to the rural areas, and therefore the temperatures which are witnessed on an average in the urban areas is significantly more. So for example, if you move from Delhi to the nearby areas, you will realize that the temperature, there is a sudden drop in temperature which you will witness, and these are called as the urban heat islands simply because these are islands of heat which have been formed due to the urbanization of these areas amongst the surrounding sea of villages.
So even if an urban center have water bodies, but there are more of the greenhouse gases in the urban center, that will be heated more as compared to the villages if it doesn't have a water body nearby.
Yeah, so I mean I didn't get your point.
Like you have said, there are water bodies in
Yes.
the villages and there are less water bodies in the urban centers. So urban centers get heated up very easily and more rapidly.
Yes.
But if there are water bodies in the city and due to more of greenhouse gases, it will get heated up easily and more rapidly as compared to villages which are having less water bodies or no water bodies, but no lack of greenhouse gases.
See, on an average, what is seen is that the urban centers do not have water bodies. They have covered drains, right? They have presence of greater greenhouse gases, and therefore the temperature which is witnessed in these areas is significantly more than the village areas. On an average, I am talking about. If you start talking about on a case-to-case basis, this is not a specific statement which I am making, but a more general statement, right? Okay, right. Then another particular factor which affects the climate is something again which has been mentioned as slope, shelter and aspect. So it says that a steep slope experiences much rapid change in temperature as compared to a gentle slope, something which I talked about, that how the southern slope of Himalayas, they are much more steeper and therefore there is a much more rapid change in temperature and the climate as compared to the more gentler slopes which are present towards the China side, right? And it also says that mountain ranges that have an east-west alignment like the Alps show a higher temperature on the south-facing sunny slope than the north-facing sheltered slope, right? And the greater insulation of the southern slope is better suited for vine cultivation and has a more flourishing vegetative cover. So this is also one socio-economic effect of it. So you will see that the population density, this is also one of the reasons, this is something which can be asked in the question, right? That why does the southern slope of the Himalayas have higher population density as compared to the northern slope of the Himalayas, right? One of the reasons for that is the southern slopes has lesser extremity of temperature compared to the northern slope of the Himalayas, right? But at the same time you have to also remember, मैं बार-बार उस चीज के ऊपर एक emphasis दे रहा हूँ, that the change in the temperature and the change in the climate in the southern Himalayas is much more than compared on the northern side of the Himalayas, and the same is applicable for the Alps also. Clear? Right? And then it also talks about El Nino as one of the effects. Human influence के बारे में तो हमने बात करी ली, that how building up of concretized structures etc. leads to a difference in the temperature of particular places. Yes.
But why this change is more on the steeper side of mountains?
Why would you tell me? Why would it be more on steeper side? No. Why would it be more on the steeper side of the mountain? Who can explain?
Rise of air and water.
Because of?
Why would water?
So okay, can you repeat your question?
Why there is more temperature
So she's saying that why, so I just said that the southern side of the Himalayas would have a steeper change in the temperature when compared to the northern side of the Himalayas. What would be the reason for that?
Altitude increases rapidly.
Obviously, altitude increases rapidly, and therefore, I mean, the normal lapse rate which we just talked about, right? That the rate of the change of the altitude is significantly more in the southern Himalayas when compared to the northern Himalayas. And उसके बारे में भी हम बात करेंगे कि that why are the southern Himalayas much more steeper when we talk about plate tectonics. See, one of the reasons why the southern Himalayas are much more steeper when compared to the northern side of the Himalayas is because you just not to confuse you, but just to tell you that you had this Indian plate which was pushing against the Eurasian plate, right? The force or the pressure from the Indian plate onto the Eurasian plate was more than the thrust from the Eurasian plate onto the Indian plate. Both of them were converging, but the force from the Indian plate was more. And because of this, there was greater pressure which was applied from the Indian side. And because of the greater pressure, say for example, if I have this sheet of paper, right? Now, if it's like this, if I apply greater pressure from this side, this would become much more steeper, right? And this, the slope here would remain to be much more gentler. So this was one of the reasons why we have a greater slope, or the altitude of the northern Himalayas, from the northern Himalayas, like the slope is much more steeper when compared to the southern Himalayas. And that's also one of the reasons, as I said, that you would see that most of the mountaineers ascend the Everest from the Nepal side and not from India side, because it is very difficult to ascend Mount Everest from India side, right? Okay, fine. Now this is about the factors affecting. So till now we have talked about the heat budget, we have talked about heat balance, right? And then we have also talked about factors affecting the climate change, right? Also, when we would also be now talking about the pressure belts on the surface of the earth, right? So this is where the real concept as far as geography is concerned starts.
Sir,
Yes.
are all these factors that you mentioned, like, are they classified based on the degree of their effect on the
No, it's very difficult, but at the same time, yes, some of them have a very prominent role. Latitude, for example, is one of the most important factors as far as the climate of a particular place is concerned, right? Altitude may or may not be a very important factor. I'll give you an example. An example is Mount Kilimanjaro, which is present in Kenya or in Africa, right? Now, what happens in case Mount Kilimanjaro has a significant height. It's significantly, right? But in spite of that, when you see the kind of climatic conditions which are present in Mount Kilimanjaro and compare them to the Himalayas, they are very different. The reason for that is because of the equatorial location of Mount Kilimanjaro. So latitude in a way overpowers all the other factors that we talked about, whether it is the altitude or whether it is the presence of the ocean currents and so on and so forth. But latitude remains to be the most important one. And if I have to say, the second most important one would be the presence of the ocean currents, because you would see that ocean currents determine how and where are the most of the deserts of the world are located. I'll talk about why and where are most of the deserts of the world are located and what is the particular reason for that, right? Okay. Now, talking about the surface of the earth, okay. So the globe or the earth has been divided into several pressure belts. There are several pressure belts which exist on the surface of the earth. So for example, this is your 0 degree. From 5 degree north to 5 degrees south, you have a pressure belt existing by the name of equatorial low pressure belt, right? Why does this, sorry? Okay. Sorry? The note says 10 degrees. No, it's 0 to 5 degrees is what you have to. Okay, I mean, generally the many of the standard text which you will refer to, it says 5 degree north to 5 degrees south. It might extend to, the reason why it says 10 degree or the notes say 10 degrees is because what tends to happen is because of the apparent shift of the sun, right? The pressure belts also tend to shift. But otherwise, the general standard as far as the equatorial pressure belts or the equatorial low pressure belts are concerned is 5 degree north to 5 degrees south.
What is the range? What is the range between the equatorial low pressure belt?
Migrates? Okay, so see, again the rate of the migration could anywhere be between 15 degree to 15 degrees south. ठीक है. But also there is a concept called as ITCZ also, so that significantly migrates a lot more, but it's generally 15 degrees north to 15 degrees south to be on the safer side. ठीक है, fine. Now, as far as the equatorial low pressure belts are concerned, so if which particular notes have this thing, pressure belts of the number 10. Okay, so I just wanted to show you people the diagram because okay, it's not present here. Give me a second. Okay, so this is the diagram which I am drawing. How many of you have Goching Liang right now with you? No one. Okay, just one. Okay, anyways, I'll just replicate this diagram which is there. Right, in next class से यार ये काम करना कि एक तो Goching Liang ले आना अपने साथ, and please get the atlas also. It will be easier for me. ठीक है. Okay. Sorry. Oxford as well as the India atlas. Right. Okay. So this is the equatorial low which is present, and this is this is your 0 degree, right? Okay. So this is the equatorial low pressure belt which exists on the surface of the earth. This equatorial low pressure belt, when we talk about it, is created due to the high temperature conditions which exist in these particular regions, right? There is direct incidence of the sun rays which takes place here, and because of that a lot of convection takes place. There is rising of the air which takes place, and therefore you have doldrums which are created out here, right? Why are they called as doldrums?
Air moves directly upward.
Okay, so the air here moves directly upwards and there is no convergence of the winds. I'll talk about why the convergence of the wind does not take place, but this is the equatorial low pressure belt which is created due to thermal reasons because of the high extensive heating of this particular region, and therefore the convectional currents which makes the pressure significantly lower in this region, right? Then you have this high pressure belt, okay, this polar high which exists near the poles. The reason for that is that the amount of insolation which is received in this part of the earth is significantly lesser, right? And because of that particular reason, the temperature remains to be much higher. There is subsidence of air which takes place. The cool air subsides in these areas, and these are pressure of high regions. These are regions of high pressure, sorry, right? These are regions of high pressure, these are regions of low pressure. Both of them have been created thermally, right? So both these belts are created thermally, the north polar high, the south polar high, and the equatorial low pressure belt. Now there are four more belts which are created on the surface of the earth, which are not created thermally but are induced dynamically. And when I say dynamically, it is these four belts are created because of the rotation of the earth, right? So what tends to happen because of the rotation of the earth is that you have these subpolar low pressure belts When you go back home, just refer figure 115 from page 110 of Goching Liang. This is the diagram I am drawing. Okay. So you have these subpolar low pressure belts which exist, and they exist at 60 degree north and 60 degree south. Fine. The reason for their creation is that as the earth moves on its axis, as it rotates, what tends to happen is that the winds from the high pressure areas tend to deviate towards the lower latitudes, and therefore there is a creation of this subpolar low pressure belt. So what tends to happen is that because of the rotation of the earth, these belts are created, these belts are induced dynamically because the wind from these particular regions, they diverge towards the subtropical areas, and therefore leading to creation of subpolar low pressure belts. right? And then, as I said, that since the winds from these areas are diverged towards the subtropical areas, that is 30° north and 30° south, you have creation of two more belts which happen here, which are called by the name of subtropical high pressure belts, right? So what tends to happen is, if I have to make it onto in another way, say, okay, this is 0°, okay, and let's say this is 30°, this is 60, and this is 90. So 0° के ऊपर air rises, right? It converges above 30° Celsius, not 30°, but above 30° latitude, and then it converges near 30°. It descends onto 30° and therefore creates a pressure of zone of high pressure, right? And then there is movement of winds from high pressure to low pressure from 30° to 0°. Clear to everyone? Is this clear to everyone? Right? You have the ascent of air which takes place near 0°, because there is high temperature which is present here, the land heats up more and therefore air ascends, because as you would know that the warmer air ascends, right? It is lighter and therefore it ascends. So this air ascends, it moves towards the 30°, and there is a descending of this wind which takes place near 30°, right? And then you have these on surface winds which blow from 30° to 0°, right? These are called as the trade winds. We'll talk about them in just a short while. And then you have these upper air winds also, which blow from 0° to 30°, right? This is also called as the Hadley cell, right? Okay, now what tends to happen that from 90° to 60°, let's see. At 90°, as I said, that the temperature is very low, because of it there is the descending of the air. So this descending of the air is happening here, and this wind moves from 90° to 60°, because 60°, as I said, is a zone of low pressure. So you have wind moving from higher pressure to lower pressure, and you have the ascent of winds also taking place near the near 60°, as I said, because of the dynamically induced pressure belts, because of the rotation of the earth. So at 90° you have descending of these airs, at 60° you have the ascending of these airs, and in the upper atmosphere again there is movement of the winds like this. ठीक है? Now comes 60° and 30° के बीच में what tends to happen? Okay, between, so these are the polar cells. So this is the Hadley cell, this is the polar cell. Now, so both of these cells are thermally induced. ये मैंने अभी बोला था कि ये thermally बनी है ये दोनों, because यहाँ पे ज़्यादा टेम्परेचर, यहाँ पे टेम्परेचर बहुत कम है, यहाँ पे टेम्परेचर बहुत ज़्यादा है, यहाँ पे ascent of winds हो रहा है, यहाँ पे descent of winds हो रहा है, and therefore these are high pressure areas, these are low pressure areas, simply because of temperature and nothing else, right? But when we talk about the subpolar low pressure belts and the subtropical high pressure belts, they have been created because of the rotation of the earth, right? Now, what tends to happen from 30° to the 60° is that you have, these are low pressure areas, these are high pressure areas. So you would be having winds moving from high pressure to low pressure, right? And you would then be having movement of the winds will be again ascending, because I said that these are areas of low pressure. The upper air winds are always opposite in direction to the surface winds. Do remember that as a fact. So as you would have seen कि यहाँ पर between 30° to 0°, the winds are going from 30° to 0°, but in the upper air it is going from 0 to 30. Similarly, 60 to 30, it is going from 30 to 60, but the upper air winds is from 60 to 30, right? And then the winds finally descend here near 30°. Okay, now अब इसको फिर से अगर पर्सपेक्टिव में देखेंगे, so see, This is a zone of divergence because you have the winds moving or ascending from here, and therefore the pressure here would be significantly lower. When we talk about the 30-degree place, at 30-degree latitude, all the winds are descending. This wind is also descending, this wind is also descending. Therefore, these are zones of convergence and therefore high pressure zones. And then when we move to 60-degree latitude, these are again zones of divergence because the winds are ascending here again. So therefore zones of divergence. And then you have again a zone of convergence which is created at 90-degree, right? Now what this all leads to is, and this is called as the Ferrel cell. There is no need for you to remember Ferrel cell, polar cell, Hadley cell. I just told it. But now let's see how do the winds move. Now there are 3 or 4 factors which also affect the way the winds move on the surface of the earth. Yes?
Can you just explain 30 to 60?
The 30 to 60. This one. So these are high pressure areas, right? The subtropical areas, and this is the low pressure area. So you would be having winds moving from high pressure to low pressure area on the surface, right? And as I said that in the low pressure areas at 60-degree north or 60-degree south, because of the rotation of the earth, the winds get diverged from here. Do not ask me the exact mechanism because I will not be able to explain it. But at the same time, for now, just understand that because of the rotation of the earth, because of the pressure which is created by the rotation of the earth, the winds at 60-degree north or 60-degree south tend to diverge, and therefore creating a zone of low pressure. Since this is low pressure, this is high pressure, winds from high pressure move to low pressure, and therefore leading to the divergence of winds again here at low pressure. This is the first part of it. सबसे पहले ये होता है, ठीक है? There is divergence of wind which takes place here, right? Because of that, subsequently the wind. So I'll tell you how it exactly happens. So एक बार और better clear हो जाएगा, ठीक है? Look at it this way. Wait. So this is 30-degree, this is 0-degree, right? I told you that low pressure, this is a low pressure zone. This is created because of the divergence of the winds, because of the rotation of the earth. The winds tend to ascend here, they rise. In the upper atmosphere, they travel from 60-degree towards 30-degree. And then they subsequently descend upon 30-degree. Okay? Because of which there is high pressure which is created here. You have descending winds here, high pressure. Now, since this is high pressure area, this is low pressure area, your surface winds are induced from high pressure to low pressure. Got it? Right? So, just understand this. ये Ferrel cell, Hadley cell और polar cell समझ में आ गया सबको? If you want me to repeat it, I'll repeat it again. नहीं है, अभी बता दो.
So can we use the concept of fronts?
नहीं यार, front कहाँ से आ गए इसमें? Front is a No. यार ज़्यादा पढ़ने का ना यही दिक्कत होती है. एक तो I'll just tell you one more thing that when you come into the class, forget about whatever you have read anywhere. ठीक है? I'll try and make the concept as simple for you as possible and try and tell you the very basics which are missed in the books. Books के अंदर front और फिर polar cell, Hadley cell वगैरह सब आप खुद से पढ़ लोगे. खुद से भी पढ़ाई करनी पड़ेगी. मैं सिर्फ क्लास से नहीं होगा यहाँ पे, मैं इतना भी बता दूंगा आपको. I give that as a caveat already. If you expect that you walk into the class, you move out of it and your preparation for geography would be done for prelims, believe me, that's not going to happen. I mean, some people might not like it, but this is how it is. It simply does not happen like that, right? In any case, so front का उससे कोई relation नहीं है. Front is a very different concept. We'll talk about it. Fronts are created in the temperate latitudes, right? Because of the meeting of two different air masses and so on and so forth. वो एक अलग चीज़ है. Air mass का concept और front और temperate cyclones अलग से deal करेंगे, right? For now, these three cells and the creation of the pressure belts on the surface of the earth are clear. Yes, tell me.
So the 30 degrees high pressure due to the convergence of the winds.
Yes.
That's the only reason.
Yes. So see, again I'll tell you what. As I said, that the equatorial low and the polar high pressure belts are created because of thermal conditions. 30-degree north, 30-degree south and 60-degree north and 60-degree south, that is subpolar low pressure belts and the subtropical high pressure belts do not have any thermal relation. They are induced or they are created dynamically And when I mean dynamically, as I said, it is because of the rotation of the earth. If earth would not have been rotating, we would not have witnessed these four belts being created, and we would have had just these polar highs and the polar lows and these, because see उल्टा भी है ना, एक चीज ये भी इंटरेस्टिंग है. Some people, अगर ये थर्मल होता, these are regions of high temperature and these are regions of low temperature, so we should have witnessed high pressure here and low pressure here. Ideally, if it would have been thermally induced, यहाँ पे low pressure होता, यहाँ पे high pressure होता, but it's the opposite. That is because of the rotation of the earth, right?
How does the rotation of Earth does induce a high pressure?
That's what I said, that do not ask me the mechanism that, how does that induce, because then I'll have to go into physics and mechanics of it, which I do not know.
It's not.
From you need not understand that. Just understand that these two are created. See, when I'll talk about the concept of monsoons, there is something which is very interesting about monsoons. I remember that this was a quote which I found somewhere, that monsoon is as simple a concept which is understood by each and every school going boy in India, but cannot be explained by even the researchers, those who are sitting in World Meteorological Department. So what I mean to say is that there are certain concepts in climatology and geography where you will have to assume a particular thing, that this happens as a phenomenon, and the explanation for that phenomenon is not available. For example, I'll just talk about tropical cyclones in a while, and no one knows that how are tropical cyclones induced. One only knows that how do tropical cyclones look like. There are only theories which are there. Some people say that because of the latent heat of condensation and this and that, but no one exactly knows. Otherwise, our predictability of tropical cyclones and monsoons would have been much better, right? Similar is the case that why are subpolar low pressure belts induced and high pressure belts induced? It's thermal. It's not thermal in origin is what you need to understand. It's dynamic in origin, right? Yes.
What's the significance of the term doldrums?
Significant of the term doldrums is that these are zones of calm. What tends to happen is that there are no winds which blow in these areas. उसके ऊपर मैं आ रहा हूँ, अभी आ रहा हूँ, ठीक है? Now, see what tends to happen in these areas. अब winds की बात करते हैं. बहुत सिंपल हो गया आप सब कॉन्सेप्ट. 5 डिग्री नॉर्थ टू 5 डिग्री साउथ या 10 डिग्री नॉर्थ टू 10 डिग्री साउथ या जो मर्जी बोलो, इसके अंदर क्या होता है that you have high temperature, the winds tends to ascend, which I already talked about. Now these winds do not converge, they just tend to ascend, and this region between 5 degree north to 5 degree south where winds do not converge is called as the zone of doldrums, because these are calm seas, right? There are no winds which are blowing there, and there is a particular peculiarity about the kind of conditions which exist, which is called as the doldrums. One is that, right? Now let's talk about the winds here first. 30 degree south to 0. अच्छा, उससे पहले मैं ये बात कर रहा था that there are 3 factors which affects the winds blowing on the surface of the earth. Okay. ये प्रेशर वाला कौन सा है डॉक्यूमेंट? 10th ना? Okay. Okay, so fortunately or unfortunately there is something else from what given. Anyways, that's not an issue at all. So I just didn't want to miss any of the factors which are there. One second. Okay. So there are 3 factors which affect the movement of the winds on the surface of the earth. The first one is the pressure gradient, right? The more is the pressure gradient. Pressure gradient means the more is the difference in the pressure between 2 areas, the faster the velocity or the speed of the wind would be, right? One is that. Second thing which affects the movement of the winds on the surface of the earth is the Coriolis force. Now this Coriolis force is again a force which is induced due to the rotation of the earth, and as a thumb rule it is seen that winds which move in the northern hemisphere are deflected towards their right, and the winds which move in the southern hemisphere are deflected towards their left because of the presence of Coriolis force. Coriolis force is a force which increases from 0 degree to 90 degree. That means that at 0 degree latitude, Coriolis force is absent, and at 90-degree latitude Coriolis force is maximum, right? That is second thing. Now the third factor which influences the winds or the speed of the winds etc. on the surface of the earth is the frictional drag of the surface. The closer a wind would be to the surface, there will be more frictional drag on it, and therefore its speed would get reduced. Therefore you will, when we will talk about some winds called as the jet streams, these jet streams are present almost 10 to 12 kilometers above the surface of the earth. And because there is no frictional drag on these winds, they move at very high velocities compared to the winds which blow on the surface of the earth. Similarly, if there are any mechanical barriers which are present on the surface, say mountains or say plateaus or say some small hill ranges etc., again the speed of the wind gets affected, right? Now these are the three factors which majorly affect the winds or the direction of the winds on the surface of the earth. The frictional drag can also change the direction of the winds. Also the pressure gradient influences the direction of the winds, because winds blow from pressure of regions of high pressure to regions of low pressure. Clear to everyone? Three factors which affect the movement of the winds on the surface of the earth are the frictional drag, the pressure gradient and the Coriolis force, right? Okay. Now doldrums के बारे में हमने बात कर ली. Now these are high pressure zones, right? 30-degree north and 30-degree south, we have high pressure zones present here. What should happen? Wind should move from 30-degree north to 0-degree north. So it should be like this. Wind should be moving like this ideally, but because of the presence of Coriolis force, as I said, that the winds in the northern hemisphere get deflected to their right, they will get deflected to their right like this. Okay? And we would have presence of these winds which blow across the year, both in the northern and the southern hemisphere, from 30-degree north to 0-degree or 5 to 10-degree north, and 30-degree south to 5 to 10-degree south. These are called as the trade winds. Why are they called as the trade winds? Because these winds were used by the sailor in the earlier times, or the traders in the earlier times, to move their ships. Right? These are continuous winds which are present there throughout the year. Okay. Now, since, and also the naming of the winds is done in a very peculiar fashion. Winds which move from a particular direction, वहां से ही उस particular wind का नाम आता है. So these winds are northeasterlies, and these winds are southeasterlies, right? Because these are coming from the northeast direction. They are also called as the easterlies. So trade winds are easterly in nature because they blow from the eastern part, or the east to west, or from north to south. So they are called as the northeasterlies. And similarly you have not the southwesterlies, southeasterlies. Southwesterlies are monsoons, right? So these are southeasterlies and northeasterlies, right? These winds do not converge, as I told you already, because as the winds approach 5-degree or 10-degree latitude, they experience high temperature, they get ascended, and there is this zone of calm which exists here, and this is also called as the doldrums. Clear? Now, also remember that there is something called as the horse latitudes at this 30-degree north and 30-degree south. Now what used to happen in the earlier times was that at times the sailors would get caught up in these high pressure zones, 30-degree north and 30-degree south, where the winds were descending, and these were the areas of convergence, as I told you already, right? Winds, all the winds are descending here at 30-degree north. Clear है सबको mind में? Wiped off that diagram. You want me to make that again? Clear, right? So 30-degree north and 30-degree south, there is a convergence of winds which is taking place, and these areas become zones of calmness where there are no winds which are blowing, somewhere near 30-degree north and somewhere near 30-degree south. What used to happen in the earlier times was that the sailors, because there were no winds, their ships would not move, because the pressure of the winds was significantly lesser to move their ships. they would throw off the horses which they had, which they were going for taking for trade or whatever. They would throw them off into the oceans to lighten up their ship so that it could move. And therefore these zones are, or these latitudes are also called as the horse latitudes. Clear? What tends to happen was that in order to lighten up their ships or their boats, and so that they could move in these zones of calm, 30° north, where the winds are descending, there are no winds which are diverging from here. These are zones of convergence, right? Because of that, there is stability, high pressure conditions which are created here, because of which the boats or the ships do not move readily. And therefore, in order to make them move, or to lighten up their load, they would throw off the horses into the oceans, and therefore they are called as the horse latitudes also. Clear? Yes.
So the north and southeasterly winds are a part of Hadley cell.
Of the
trade winds that you mentioned right now. They are an integral part of the
Hadley cell. Yes, the northeasterlies and the southeasterlies are the part of the Hadley cell. Okay, fine. Now let's talk about what kind of winds blow here, right? Again, this is a polar high, this is a low pressure belt, this is also a low pressure belt, this is a polar high. So we'll be witnessing winds which should have been moving ideally in this direction from polar high to this thing, but that does not happen. So you have these winds also, which resemble their movement exactly like the trade winds, and they are called as the northeasterlies and the southeasterlies, right? Clear? So these are the two winds, these are the two kind of winds that we have talked about till now. So when we talk about the trade winds, these winds are present almost throughout the year, right? They blow throughout the year. These are permanent winds on the surface of the earth. There are certain winds which blow on a temporary basis also, and they are called as local winds. We'll talk about them just right now, right? And then you have the third kind of winds, right? These are zones of high pressure, these are zones of low pressure. We talked about how on the surface there are winds which are blowing from low pressure to high pressure, from high pressure to low pressure, and these winds ideally should have been blowing like this, but because of the Coriolis force they tend to get deflected towards their right, and therefore instead of blowing like this, they tend to blow like this. And since they blow from the westerly direction, they become they are called as the westerlies, right? Also another point is that, yes, yes, high pressure to low pressure. Clear? So again, इसको ना पूरा एक बार यहाँ पे ये फिर से देख लो. This is important to understand in a way. This is your 0°. This is your 30°. This is high pressure. This is also high pressure, 30°. This is 60°, which is low pressure. This is also low pressure, 60°. And then you have high pressure zone present here and high pressure zone present here. Clear to everyone, right? So therefore you will be having winds which will be moving in which direction? Like this, right? And similarly like this. Similarly in this region it would be blowing like this, and in this region it will be blowing like this. Okay? And when we talked about the westerlies, from high pressure to low pressure, they should have been ideally moving like this, but they will get deflected to their right, so they will become like this. Okay? And similarly they should have been moving from here to here, but they will get deflected to their left, so they will become like this. Okay? And since they are going from the west direction, they are called as the westerlies, right? Also what tends to happen very interestingly in the southern hemisphere is that these westerlies move at a very rapid speed and rapid velocity. The reason for that is that you hardly have any landmass which is present near 60° or 40° or 50° on the map of the earth. So see this where my hand is, this is 40°. My thumb is at 40°. So you will see that there is hardly any landmass which is there near 40°. Okay? 50° पे आओगे, this is 60° where my thumb is right now. You have no landmass at all near 60°. And 50° there is again some landmass. So These winds or the westerlies which blow throughout the year in the southern hemisphere at the latitudes of the 40 degree are called as the roaring 40s, the furious 50s, and the shrieking 60s, right? So they blow at rapid speed, rapid velocities throughout the year in these latitudes without any disturbance of any landmass. Because मैंने frictional drag की बात की थी, frictional drag से speed कम हो जाती है. कोई भी अगर wind जा रही होगी, अगर नीचे land होगा, landmass होगा, कोई mountain होगा, so their speeds would get reduced. But there is no landmass which is present here between 40 degree to 60 degree. And these westerlies blow almost throughout the year in a complete westerly direction also. That is also, the reason for that is that because what tends to happen is the higher the speed of a wind, the more effective would the Coriolis force be. Okay. So in these regions, since the speed of the winds is also very high, Coriolis force also tends to be having more effect. And what tends to happen because of that is that the winds in these direction, instead of blowing in the north westerly direction, would blow completely in the westerly direction. Clear? So these are the westerly winds as far as the southern hemisphere is concerned. The same is not true for the northern hemisphere. Northern hemisphere, it's a very different story because you have huge amount of landmass which is present there. This is 40 degree, right? This is 60 degree. So see, 60 degree, 40 degree. Substantial landmass which is there. The Africas, some part of the Americas and Europe and then the Asia. Okay. Okay. So this is as far as the planetary winds are concerned. Any doubts on planetary winds? Yes.
So, why this wind, the subtropical wind, between 30 to 60 degree south, why they tend to get to left, to their left?
Where? They tend to move to the left before it goes the Coriolis force.
So then,
In the northern hemisphere, Coriolis force tends to deflect the wind towards the right. In the southern hemisphere, the Coriolis force tends to deflect the winds to their left.
this is fundamental.
ठीक है? Yes.
So the wind blowing in subpolar low pressure and polar high pressure, there are also known as trade winds.
Sorry? The subpolar and the high, no, they are not called as the trade winds. They are called as the easterly. They are trade winds. ये वाली ही कहलाती हैं specifically. Directions are same. They are called as the trade winds because sailors used to use these winds to trade. ठीक है? These are not called, so trade winds उसका geographical reason नहीं है, such एक historical reason है. Similar to what I told that this is horse latitudes or these are roaring 40s and 50s and so on and so forth, right? Yes. So one second. Yes. No, I mean again, so this is, so he was asking about how do the centripetal force, acting. It is actually the combination of the centripetal and the centrifugal forces, which again I'll have to go into the physics of it. For now, just accept it as a thumb rule that the winds in the north get deflected to their right from the direction of their origin, and the winds in the south get deflected to their left from the direction of their origin because of the presence of Coriolis force. Do not be bothered about why does that particular thing happen, because that's not going to be asked. That's completely physics. Similar to, just to reply to your question about the centripetal force, again the centripetal and the centrifugal force is actually what is causing the Coriolis force coming into the effect, right? So you could just ignore that concept. That I'll admitted that even I do not know it, and for a simple reason that you need not know it for the purpose of this exam at all, right? This is physics, completely physics, and physics where you will have to then apply models in order to understand that why it deflects to right and left and so on and so forth, right? Fine. Any other doubts on winds, the planetary winds? These are also called as the planetary winds because they blow across the planet. These are also called as the permanent winds because they blow permanently throughout the year, except in some cases such as the monsoons, where these northeasterlies are replaced by the southwesterlies, but that is also a very local phenomenon. Monsoons are not witnessed across the world. It is a phenomenon which is specifically restricted to some regions of the world. Everyone is clear about this, right? Another concept which is related to this particular aspect of the southeasterly and the this thing, and वो हम Mediterranean climate जब पढ़ेंगे तब हम उसके बारे में बात करेंगे, but let's talk about it right now also, right? What tends to happen is, as you all would know, that during the summers there is an apparent shift of the sun which takes place. So instead of the oblique or the straight rays of the sun falling at 0 degree, they tend to heat up the northern hemisphere more in when there is summers which is being experienced in the northern hemisphere. Because of that, this 0 degree in a way shifts 5 degrees, and all these pressure belts also tend to shift 5 degrees or 10 degrees during the summers in the north, and similarly during the summers in the south also. So जब summers in the north होता है, that is basically the month of June, July, what tends to happen is that these pressure belts that we talked about, 1, 2, 3, 4, 5, 6, whatever, they tend to shift 5 degree north, all of them, right? Because of that, what tends to happen in the summers is that some of the regions which were under the influence of trade winds in the southern hemisphere come under the influence of westerlies. I'll tell you how. Give you an example. This is the coast of okay. This is the coast of Chile, right? So if you look at the latitudes, this is 30 degree and this is okay. So this is 30 degree latitude and this is 40 degree latitude, right? And this is central Chile. So basically central Chile falls between 30 degree to 40 degree latitude, right? Ideally here at 30 degree, what we should have been witnessing, these winds blowing from 30 degree to 0 degree in the form of easterly winds, right? These would have been easterly winds which have been blowing out of Chile onto the sea. That means they would have been dry winds, since they would have been blowing from the land to the sea. That means that they would not have been carrying any moisture also. That also means that they would not have caused any precipitation, right? But now, because of the apparent shift of the sun, what tends to happen is that this part of Chile near 30 degree tends to suddenly fall under the zone of westerlies. Because यहाँ पर जो westerlies थी नीचे, जो 30 degree के that were beyond 30 degree, 30 to say 60 degree, suddenly there is this shift of these winds which takes place because of the shift of the pressure belts. Pressure belts are shifting, and therefore this zone comes under the influence of the westerlies. Now these westerlies blow in the westerly direction like this from the sea to the land, and therefore carry moisture and thus cause precipitation at the coast of Chile. So these regions are called as regions of Mediterranean climate, where so जब यहाँ पर summer witness हो रहा है, southern hemisphere में winters witness हो रहे होंगे, and during the winters Chile experiences rainfall, winter rainfall. So the places which have dry summers and wet winters experience this peculiar kind of climate called as the Mediterranean type of climate. This Mediterranean type of climate has several socio-ecological implications. You would have heard of places, so you would have heard of vines, right? So some of the best wines of the world come from the Mediterranean climate, from France, from Italy, from Spain, etc. Port wine you would have heard, that comes from Portugal, right? So the best wines of the world come from these regions. That is because the best cultivation of grapes and vineyards and a large number of such citrus fruits such as your lemons and oranges and tomatoes, etc. takes place in cool and wet climate, which is experienced only in these Mediterranean places. Clear? So this is one of the effects of the shifting of the pressure belts. Mediterranean climate के बारे में और we'll talk about it in detail when we talk about all the other climates types of the world. We'll be giving at least 2 classes to discussing all the climate types of the world. Clear? This particular part is clear to everyone? Okay, fine. Okay, now since we are done with the planetary winds, let's move on to something called as the phenomenon of local winds. Very simple phenomenon. There is nothing too difficult to understand in it. गजेंद्र जी वो असाइनमेंट्स आ गए हैं, एक बार चेक कर लो, क्लास असाइनमेंट्स प्रिंट हो गए नहीं है. Okay, so let's talk about something called as local winds. Now see, there are local winds also. These are there are various kind of local winds which are there. One is the नहीं हाँ दे दो, चलो दे दो. बस और मत लाना. Okay, so there are several kind of local winds which are there, which blow in only some particular regions. One example of local winds is the land breeze and the sea breeze. As you all would know that we talked about the specificity of the heat, specific heat of the land is more compared to the specific heat of the water. That is, land tends to get heated up more quickly than the water. Now during the day what tends to happen is that the land gets heated up very quickly and the sea does not get heated up as much as the land. Because of that, there is a low pressure zone which is created on top of the land during the summers, during the day. What tends to happen on the other hand is that there is high pressure zone, relatively there is presence of high pressure when compared to the land on the top of the sea. Therefore, there are something called as sea breeze which blows during the day from the seas to the land, and these are local winds, right? Now similarly, during the night the land tends to lose its heat more quickly than compared to the sea. Therefore, there is high pressure which is established over the land and low pressure which is established over the sea, and winds move from the land towards the sea in the form of land breeze, right? Now there are several socio-economic implications of these land and the sea breeze. What are they? The first one is that they tend to bring relief to the people of those who are living in these regions, right? So the cool sea wind or the sea breeze which blows during the day helps to lower the temperature of these coastal areas and therefore make the climate less oppressive for the people living in these areas. One is that. Second is also that there is a economic implication of this. Economic implication is that a large number of sailors tend to sail during the night because there are breeze which are blowing from land towards the sea. And when you go to the port of Bombay, etc., you will see that most of the ships would leave their ports during the night when there is sea breeze which is blowing. Therefore, lesser energy would be required, or there will be a help which will be provided to these ships to sail into the seas, right? Because of the presence of sea breeze, because of the presence of land breeze during the night. Clear to everyone? Okay. Now there are other kind of local winds also which are present. We know about the fawn winds and the Chinook winds. Chinook winds I already talked about. These are also called as the snow eater winds, which are leeward winds, which move from the western part of the Rockies to the eastern part of the Rockies, and therefore by the time they reach the eastern part of the Rockies, these are hot and dry in nature, and they eat up the snow which is lying in the Californian plains, and therefore make the conditions less oppressive for people of those regions. Similarly, you have the fawn winds. The fawn winds also have a similar kind of a nature. They move from, again, the southern Alps to the northern Alps, and by the time they descend towards the northern Alps, they bring dry and hot conditions to some of the regions near Switzerland, right? So as I'll read it, that the fawn wind is experienced in the valleys of the northern Alps, particularly in Switzerland in spring. Chinook winds are experienced on the eastern slope of the Rockies in the USA, right? And Canada in winter. Okay. Then apart from these, there are a number of other winds also. There is Mistral and there is Harmattan, Sirocco, etc. So whenever we are discussing the map of the world, we will talk about what are these Harmattan. Harmattan are also called as the doctor winds. Why are they called as the doctor winds? Because these are dry winds, and they actually they provide relief to the people from the humid oppressive conditions which exist in those regions, and therefore they are called as the doctor winds. Then we have large number of other winds which are there. So we'll talk about all those Sirocco winds. Sirocco winds bring red color rainfall because they are blowing over the Italian plains, and then they bring the red particles, and therefore they shed blood. That's also called as a blood rain, and so on and so forth. We'll talk about all these rains and all these type of winds later on when we talk about the world map, right? Okay. Now coming to the last two topics of the day. One is the tropical cyclones, and then is jet streams, and related to that is the concept of western disturbances. Okay. First of all, talking about the tropical cyclones. So I'll just read out something from the notes. These are my notes, not the notes otherwise. So yes, so the tropical cyclones are, these are low pressure systems. First of all, try and understand what are tropical cyclones. We keep hearing that a tropical cyclone is occurring, or a cyclone is going to hit the coast of Odisha or Andhra Pradesh and so on and so forth every now and then during the months of October, November. So these are what the tropical cyclones we are talking about. So tropical cyclones are low pressure systems which originate only in the tropical areas. One is that, very simple. And since these are thermal systems and they are also called as the warm core. There is another name for tropical cyclones. Warm core. ठीक है, warm core, WARM core, ठीक है. Now as far as the diameter, some of the physical characteristics, let's first talk about some of the physical characteristics of these cyclones and what are these phenomenon. So I'll give you the structure of how we are going to proceed as far as tropical cyclones are concerned. First we will talk about what is the physical characteristics and what are the characteristics of these tropical cyclones. Then we are going to talk about the kind of structure these tropical cyclones have. Then we are going to talk about the regions in which these tropical cyclones occur, and in between this we will also be talking about the conditions which are required for the existence or the formation of the tropical cyclones. Right. Now, as I said, the tropical cyclones are low pressure systems. They are having low pressure at the core of them, and these are cyclonic in nature. Cyclonic in nature means that there is convergence of winds which is taking place into these systems. Convergence of winds. You remember when we talked about 30° north and 30° south and divergence of winds taking place? Those regions are called as the anticyclonic regions. Anticyclonic. Sorry?
30° north, 30° south is supposed to be convergence point.
Huh? No, sorry? Oh, so 30° north and?
30° south.
Okay, I'm sorry, I confused it. Right. It's the 60° north and the 60° south. When we talked about these as zones of divergence, these are supposed to be the areas of anticyclonic. I'm really sorry. So these are supposed to be the area of anticyclonic activities, and cyclonic activity is synonymous with the convergence of the winds, and therefore the winds come into these particular areas. Whereas when we talk about anticyclones are high pressure systems which exist in certain parts of the world from where winds diverge. And whereas when we talk about the cyclones, these are low pressure systems where the winds converge. Now tropical cyclones are low pressure systems and they are thermally induced. They are created because of thermal characteristics, of thermal origins hai inke, right? Now as far as the diameters of the cyclones are concerned, the tropical cyclones, they typically have a diameter somewhere between 100 to 200 meters. ठीक है? And when you compare them to temperate cyclones, which we are going to talk about later, temperate cyclones are also called as the extratropical cyclones. These cyclones occur in the temperate regions of the world, whereas tropical cyclones, as the name suggests, occur in the tropical regions of the world. Clear? So the tropical cyclones, the general diameter of them is 100 to 200 kilometers, not meters, sorry, 100 to 200 kilometers. Whereas when we talk about the temperate cyclones, their area of expanse or area of extent is anywhere between 1500 to 2000 kilometers. Okay, it can go as high as 2000 kilometers. Whereas when we talk about the tropical cyclones, the radius or the diameter is at maximum 100 to 200 kilometers. Now these are cyclonic in nature, and the cyclonic systems are always anti-clockwise in their direction. So the movement of the winds within these systems takes place in anti-clockwise direction, whereas in the anticyclonic systems it is clockwise in nature, right? And this is when I am talking about the northern hemisphere. When I talk about the southern hemisphere, this is again because of the Coriolis force. When we talk about the southern hemisphere, the cyclones are clockwise in nature, right? And then the anticyclones are anti-clockwise in nature. So remember that as a rule, right? Okay. Now the speeds of these cyclones is somewhere between 175 to 150 kilometers per hour. The speed at which the winds move in these systems, the low pressure systems, is anywhere between 75 to 150 kilometers per hour, and if they exceed 150 kilometers, they are called as super cyclone. Something which we had witnessed in Odisha in 99-2000, a super cyclone had occurred in Odisha and which had caused widespread destruction, right? Now, another characteristic which is associated with the cyclones is that the rainfall which the cyclones cause is convectional in nature. Okay, so there are three types of rainfall which are there. One is convectional, the other one is orographical, and the third one is the frontal precipitation. We'll talk about them later, but for now just understand that convectional rainfall or convectional precipitation takes place because of the ascending of the airs and therefore them not able to hold moisture and shedding it off. That is called as convectional rainfall. That is purely thermal in nature. Clear? Okay. Now another characteristics of the tropical cyclone is that they do not have any defined stages. In temperate cyclones, when we'll study later, we'll be getting to know that there are 4 or 5 stages which are there in the life of a temperate cyclone. First is there is a frontogenesis, and then there is an occlusion stage and the closing of the front, and then there is a frontolysis, etc., which takes place. Here, as far as the tropical cyclones are concerned, there are no specific stages which are present. One is that. Second is that the duration of tropical cyclone is anywhere between 2 to 3 days. They dissipate very quickly. Whereas when you talk about temperate cyclones, some of you might be just thinking, why am I drawing this comparison again and again when we are not studying temperate cyclones right now? But I just want to make it clear so that once we study temperate cyclones, I need not repeat that these are the differences, because उस समय आपको ये differences obvious लगने लगेंगे बहुत, right? So the temperate cyclones, as far as they are concerned, the duration of temperate cyclones is anywhere between 15 to 20 days. Whereas when we talk about tropical cyclones, they are anywhere just between 2 to 3 days, right? Okay. Now, now what is the reason for the formation of the tropical cyclone? What formation of the tropical cyclones? See, the genesis of these low pressure systems or the tropical cyclones is still not very well known. And but there are some of the correlated conditions which make these tropical cyclones more likely in nature. So even though we do not know that what causes tropical cyclones exactly, but we do know that there are certain conditions which are a prerequisite for the existence of tropical cyclones, right? One is that the sea surface temperature in which these tropical cyclones originate should be more than 27 degrees Celsius. Yesterday when I was taking the open class, I wrongly mentioned it as 25 degrees Celsius. I correct myself, it should be 27 degrees Celsius. The sea surface temperature should be greater than 27 degrees Celsius, and therefore you will see that tropical cyclones do not originate in temperate latitudes because the temperature of the sea is lower than 25 degrees Celsius, let alone 27 degrees Celsius in those regions. Again, the reason for that is because of the insolation which is received by those places on the earth. ठीक है? Clear? Now, second condition which is required for the existence or the formation of a tropical cyclone is the presence of Coriolis force, because as I told you that these are circular systems where winds blow in a circular pattern within these systems, and that happens because of the rotation of the earth or because of the presence of the Coriolis force, right? So the presence of Coriolis force is a very important condition as far as the tropical cyclones are concerned. If you do not have Coriolis force present in these areas, tropical cyclones will cease to exist. Therefore, you do not witness any tropical cyclones in the equatorial regions in spite of the sea having high temperature. The sea surface temperature in the equatorial regions is close to 27 degrees Celsius. But in spite of that, we do not witness any tropical cyclones because there is zero Coriolis force which is present in these areas, right? 2. Then the third condition, which is actually one of the most important conditions for the existence or the formation of a tropical cyclone, is that they are formed only over sea. They are not formed over land. The reason for that is that they derive their energy from latent heat of condensation of these warm waters. They are like thermal engines which operate on the energy which they derive from latent heat of condensation which is released because of high temperature of these water bodies. So therefore, tropical cyclones occur only and are formed only over the seas. Clear? So first of all, we talked about some of the characteristics of the tropical cyclones. I'll come. Tropical cyclones, that their radius or their diameter, is somewhere between close to does not exceed anywhere close to 100 to 110 kilometers. Second, their speeds vary somewhere between 75 to 150 kilometers, even though there can be cyclones which might have a significantly lesser speed, or there might be cyclones which might have greater speeds than 150, which will be called as super cyclones. Then we talked about that the duration of these cyclones are somewhere between 2 to 3 days. There are no stages, clear stages which are present as far as the tropical cyclones are concerned. And then the rainfall which is associated with the tropical cyclone is convectional in nature. Clear? Now, then we moved on to some of the reasons or some of the conditions which are required for the formation of the tropical cyclones. We need to have temperature greater than 27 degrees Celsius. Second, there is a need for having Coriolis force, right? And the third one is they are formed only over the water bodies. The simple reason for that is that they are heat engines which are formed or which work due to the latent heat of condensation which is released by these warm water bodies, right? So far so good? Yes. Clear? Okay. Okay. Now let's talk about the structure and the weather conditions which are associated with the tropical cyclones. So these are huge structures which are there associated with the tropical cyclones. I am drawing the diagram which is given in your Goching Leong only. Okay. So how does it do? Okay. I am just adding a few things to the diagram which have been mentioned in the Goching Leong. They are just for your extra knowledge. And So again, a rough diagram which I am drawing. Again, you need not go into the diagram kaisa hai and all that thing. That just be bothered about the structure of the tropical cyclone. First of all, is there is something called as the eye of the cyclone, right? So this is a zone of central low pressure. You can write this down. You can take notes of this. The eye is the zone of central low pressure. The eye is the zone of central low pressure where the converging winds do not mix. Yes.
This being a low pressure area, how come the wind converge onto?
So I'll explain that. Just write it for now. See, the winds do not converge beyond the wall of the eye. So there is a wall of the eye which is somewhere between 1 to 1.5 kilometers in its thickness, and winds do not converge beyond this. Winds only converge till the wall of the eye and then they rise up. Therefore, you will see that I have not drawn any winds within the eye as such. So the winds rise up and they approach near the wall of the eye. Clear? So these are zone of low central pressure where the converging winds do not mix. They are something similar to the doldrums of the equatorial region. Okay, so these are इसको आप doldrum ही मान लो एक तरीके से, that there is no convergence of winds which is taking place. They rather rise up in these areas. I is a zone of calm with light variable winds. I is a zone of calm, CALM, with light variable winds and clear bright sky. Clear bright sky. I'll repeat it again. I is a zone of central low pressure where the converging winds do not mix. It is a zone of calm with light variable winds and clear bright sky. It is a zone of calm with light variable winds and clear bright sky. The diameter is close to 5 to 10 kilometers. The diameter of the eye is close to 5 to 10 kilometers. Eye wall is a zone of 1 to 1.5 kilometers around the eye. Eye wall is a zone of 1 to 1.5 kilometers around the eye with extremely strong winds and heavy rainfalls. Eye's wall is a zone of 1 to 1.5 kilometers around the eye with extremely strong winds and heavy rainfall. Eye wall is a zone of 1 to 1.5 kilometers around the eye with extremely strong winds and heavy rainfall. Clear? Now I hope that you've been able to understand wo jo doubt tha ki that when the winds are not converging and when they are not mixing up, how can the wind rise up? So basically, since the winds are not converging, it's near the eye wall where the winds actually rise up and where you witness heavy rainfall in this particular region of the eye wall, which is anywhere between 1 to 1.5 kilometers in its thickness. Clear? Okay. Now then there are these three zones which are there, into which the entire structure of the tropical cyclone is also divided. They are called as A, B and C, or they are called as the outer zone, the inner zone, the outer zone and the periphery zone. This is the inner zone. This is the outer zone and this is the periphery zone. Clear? Inner zone, outer zone, periphery zone. Fine. Now the inner zone, ये भी आप नोट कर सकते हो, is a zone of strong updraft. The inner zone is a zone of strong updraft rising air with heavy rainfall including hailstorms. The inner zone is the zone of strong updraft rising air with heavy rainfall including hailstorms. So in this particular inner zone you also witness hailstorms. When do hailstorms occur? Hailstorms occur when the velocity of the rising wind is so fast that it rises up at such a quick rate that it gets cooled very quickly, and because of that there are hailstorms which occur, right? Ole padna jisko kehte hain. Fine. Then we talk about the outer zone. This is the zone of downdraft. So winds do not ascend here, rather they come down. This is the zone of downdraft, and it is a zone of relative calmness. Clear? And then we talk about the peripheral zone or the periphery zone. We have strong winds and scattered clouds. Strong winds, scattered clouds, and erratic light rains. So three characteristics of this zone are strong winds, scattered clouds, and erratic rains. Fine. So these are the weather conditions which are associated with the tropical cyclones. Clear? Okay. Now see, the tropical cyclones are called by different names across the globe. They are so if I read out from Goching Liang, it says that tropical cyclones, typhoons, hurricanes and tornadoes, all these are different kind of tropical cyclones. They are well developed low pressure systems into which the violent winds blow. As I told you that these are low pressure systems, well developed, into which winds blow because they are cyclonic in nature. Zones of convergence. Typhoons occur in China Sea. The tropical cyclones, when they occur in the China Sea, are given the name of typhoons. When they occur in the Indian Ocean and in the Bay of Bengal, they are given the name of tropical cyclone. When they occur in the West Indian Islands and in the Caribbean, they are given the name of hurricanes. In the West Indian Islands and in the Caribbean Islands, they are given the name of hurricanes. They are given the name of tornado in Guinea lands of West Africa. Guinea lands of West Africa. I'll show you where Guinea, the coast of Guinea is. Sorry? This is what?
Where is this? Which cyclone we are talking about?
We are talking about tornadoes. ठीक है. Guinea lands. These are tornadoes which occur here. Tornadoes also occur in the Gulf region of North America. Gulf region of North America. Gulf region of North America. This is Gulf of Mexico and the states near, which are these states? Your Austin and Texas, etc., Florida, etc. They witness tornadoes, right? And then you have the name of Willy Willies, which is given to the cyclones in Australia. ठीक है. So different names are, then they are also called by the name of Baigu. In Philippines. Different naming, that's it. Nothing more fancy about it. Plus, when there is a very peculiar scheme of naming the tropical cyclones also. we'll have a question in the assignment, so we'll discuss that and you'll get to know more about it. वो हो गया क्या assignment? Print हो रहा है अभी? 33 कौन से में? सॉरी 10 में. हाँ जी बताइए. First para. It says the tropical cyclones develop from the warm core of extremely low pressure area in the tropical ocean areas. This is clear. They. हाँ. हाँ. हाँ यही तो मैंने अभी एक्सप्लेन किया. कॉन्फ्लिक्टिंग क्या लग रहा है? So the I, it says, is the center of the cyclone around which the strong spiraling winds circulate in the mature tropical cyclone. It is a region of calm with subsiding air. Subsiding air means air descends down here into the I. This is a zone of calm. That's why stability is there in this. Rising air is in the wall. तो ये actually अगर ये diagram से confusion हो रहा है तो मैं ये बता देता हूँ. ये this is the I wall and this is the I. ठीक है? ये wall है. So wall you have rising air and there is an anti-cyclone which is present at the top of the cyclone. यहाँ पे तो cyclonic condition होती है पर यहाँ पे anti-cyclone होता है. And इस anti-cyclone से subsiding air आती है नीचे जो कि इस पूरे system को work करती है. The rainfall will not be happening in the eye. It will be happening around the eye. It will be happening in the inner core, the outer core, and will be erratic in the periphery zone. मैं अभी लिखवाया तो ये सब. क्या confusion क्या है बताओ? Then it says that eye wall there is a strong spiraling ascent of air to great height reaching the tropopause. Ab, I didn't want to complex that, you know, make it complex for you people in terms of I tell that it reaches the tropopause or that whatever. यहाँ पे आई वॉल के अंदर winds are rising. मैंने यही तो लिखवाया आपको. ठीक है? And then it says the torrential rains occur here. That's what I said, that there are huge heavy rainfall which occur with hailstorms in this particular region. Hailstorm, right? And then from eye wall rain bands may radiate in trains of cumulus and cumulonimbus clouds and so on and so forth. The diameter of the circulating system can vary between 150 to 250 kilometers. The diameter of the storm over the Bay of Bengal was somewhere between 600 to 1200 kilometers and so on and so forth.
इसमें जो outflow है, what is that and what is the rain band की diagram है?
हाँ. Outflow of. So see again the outflow is, this is the eye wall and this is the rising air which is there, which is going to, so there is rising air, updraft हो रहा है यहाँ पे. मैंने बोला ना zone of updraft है. यहाँ पे तुम्हारा ये A और इसके अंदर तुम्हारा ये rising air है. And this then, you know, diverges like this. Cumulonimbus clouds. तो मैं बनाया ना ये ऐसे, ये देख ऐसे मेरी ड्राइंग अच्छी नहीं है यार. तो these are cumulonimbus clouds only. ऐसे anvil top clouds होते हैं ये. ऐसे फिर से अच्छी नहीं है यार. ऐसे they are anvil tops clouds जिनका ना मतलब नीचे एकदम flat होते हैं ये. And they are very huge and tall and dark clouds.
How these clouds are significant in making cyclones?
These clouds are not significant in making cyclones. These clouds are an effect of cyclones.
We will read it in the clouds.
हाँ, so clouds जब हम पढ़ेंगे तो I'll tell about cumulonimbus clouds and
How it is damaging when it lands on the land?
how it is damaging. And see, because this cyclone is deriving its, see, why is this updraft happening? This updraft is happening because of the low pressure system which has developed over the sea because of high temperature. ठीक है? And when it hits the land, that particular source of its energy, that is the latent heat of condensation, ceases to exist, and therefore it dissipates and diminishes. So जनरली आपने नोटिस किया होगा कि साइक्लोन का जो इफेक्ट होता है वो ऐसा नहीं होता कि एक बार साइक्लोन आता है, विंड्स ब्लो एट वेरी यू नो रैपिड रेट एट ह्यूज वेलोसिटी, दैट इज व्हाट कॉजेज डैमेज. 150 से आप इमेजिन 150 किलोमीटर्स पर आवर इफ द विंड इज ब्लोइंग, यू विल बी ब्लोन अवे, राइट? सो दैट the wind is the one which causes the damage. And then also what happens because of the winds is that you have torrential downpour which takes place, large number of your water bodies get flooded, and that leads to floods, right? And also what happens because of this winds and because of this torrential downpour is, if there are say water bodies like your कोई आपके लेक या कोई यहाँ पे छोटा पॉन्ड वगैरह है, तो उसमें भी ripples are created and there are siege and storm surges which are created in these water bodies also, which again leads to the flooding of these bodies and therefore widespread destruction. As such, tropical cyclone does not causes any destruction, it causes rainfall, but the speeds at which the winds blow cause the exact destruction. ठीक है? Okay, fine. So, and then the impact of the humans is given in your notes. It says that they are one of the most devastating natural calamities. This is page number 34 of material number 10. And they say that they move over to the coastal areas, bringing about large-scale destruction caused by violent winds, very heavy rainfall and storm surges. And trees are uprooted and broken and loose objects are swept away. A particular location of the land surface encounters opposite winds twice from circular fashion of cyclone. These winds create more damage to the objects and so on and so forth. So all that is as far as the human impact of the cyclones is concerned, right? So this is about the cyclones now. Now jet streams is a concept which I think will take a bit more time to explain. So therefore I am not taking it up in this class. We'll take it up in the next class. But we'll talk about western disturbances till then. Okay. So we'll just talk about, and western disturbances के अंदर इतना कुछ ज़्यादा बात करने का है नहीं, but it's just that we need to understand what is the impact of western disturbances. See, there are these, I talked about temperate cyclones. These are low pressure systems which develop in the temperate regions of the world, right? Now there are weak cyclonic circulations which originate over the Mediterranean Sea also during the months of winter, somewhere around November, December. Okay. Now these temperate cyclones, when they originate, or these cyclonic circulations, weak cyclones which they originate over the Mediterranean Sea, they get transferred from the Mediterranean Sea to the northwestern parts of India with the help of jet streams, and they are called as western disturbances, right? The significance of western disturbances, it has positive as well as negative implications. Yes. So what happens is that over the Mediterranean Sea there are low pressure systems which are developed, right? These low pressure systems, again low pressure systems, as I told you, are cyclonic in nature. They are associated with some type of rainfall, because low pressure systems would mean that there will be some ascending of the air which would be taking place, and therefore there will be some precipitation associated with it, right? So these low pressure systems are transferred from the Mediterranean Sea to the northwestern parts of India and Pakistan with the help of jet streams. ठीक है? What are jet streams? For now, just understand that jet streams are these winds which move in the stratosphere or the upper troposphere around 10 to 12 kilometers above the surface of the earth at very huge velocities. Velocities which are more than 300 kilometers per hour, right? So these are these core of these winds which are moving continuously in the upper atmosphere, and they transfer these, and they are westerly in nature. They blow from west to east across the globe. So they transfer these temperate cyclones or these weak cyclonic systems which are established over the Mediterranean region during the winter seasons, during the months of December, January. And they bring these temperate cyclones or cyclonic systems over northwestern India and Pakistan and cause rainfall and precipitation in these regions. Clear? Now, there is a certain significance of these western disturbances. Now, one is that all the meteorologists in India, whenever they are not able to explain any rain which happens in the month of December and January, they blame it on the western disturbances. So they, even if they are not able to explain the entire phenomenon, this is very common, they just blame the entire thing on poor western disturbances. One is that. Okay. Now coming to the serious thing. So what are the implications? See, the most important thing is that at times the rabi crops which have been planted by the farmers in western Uttar Pradesh, areas in and around Haryana, Delhi, Punjab, northern Rajasthan, etc., get destroyed because of the winter rainfalls caused due to the western disturbances. They are disturbances because if you see India, there are northeast winds which are northeast trade winds which blow from land to sea during the winters. Everyone knows about it, right? India जो है, India के अंदर जब winters के अंदर there is a low temperature which exists over the land surface, and therefore that's a zone of high pressure. Comparatively, when you look at it, there is low pressure which exists over the sea, and therefore winds blow from high pressure to low pressure in the form of northeasterly trade winds, and therefore there has to be no business of them causing any rainfall because they do not carry any moisture. So therefore India on an average in general should not witness any winter precipitation. But these western disturbances, they are called western disturbances because they come from the western areas, they are carried by these jet streams and they shed moisture over the northwestern parts of India and Pakistan and some adjoining regions in the form of their disturbance to our climatic system, right? Now, the another significance of these western disturbances is that they help cause snowfall in the foothills of the Himalayas and some part of the northwestern Himalayas. What that leads to is the maintenance of the supply of water for the perennial rivers of India during the summers. Why? Because जब snowfall होता है, that snow is what melts during the months of your June, July, August, etc., and therefore leads to a perennial flow of the Indian rivers during the months of summer. Otherwise, if it would not have been for the western disturbances, we would have witnessed significantly lesser concentration or lesser volume of the rivers in India during the summer seasons, especially of the perennial rivers of the Himalayan region, right? Your Ganga, Yamuna, etc., right? So this is as far as the western disturbance is concerned. Plus, apart from that, several other regions such as Delhi, say something like Delhi or state like Delhi would have witnessed average precipitation of anywhere close to 25 to 30 centimeters, but the average precipitation of Delhi goes up to almost 50 centimeters because of the western disturbances, right? So winter rainfalls which are caused during the months of December, January are called as western disturbances, and they are transferred by the jet streams, and these are cyclonic depressions, or these are cyclonic systems or weak cyclonic systems which are transferred from the Mediterranean Sea to the northwestern parts of India and Pakistan and the adjoining regions, right? Now, another thing which I actually missed during talking about the tropical cyclones is that some people ask that why do tropical cyclones occur only during the months of October and during the months of your November, etc., right? आप सारे जो देखोगे सब ये cyclones October, November के आसपास ही आते हैं. The reason for that is that water as a body takes more time to get heated up, and it is only during the late summer is water able to achieve that temperature of more than 27 degrees Celsius and the tropical cyclones occur. Clear? Fine. Now, वो हो गया क्या हुआ? पूछ दो यार, मतलब class. अच्छा, okay. Now, moving on to something again related to tropical cyclones before the worksheet comes and we do a few questions. There was a question which was there last year in the prelims, that why do we not see any tropical cyclones in the southeast Pacific and South Atlantic region. So I'll show you what I mean by southeast Pacific and South Atlantic region. This is your Pacific region. This is Pacific. Southeast Pacific कौन सा होगा? ये होगा, right? This part. So this is entire Pacific Ocean. ठीक है, ये और ये. Southeast Pacific is this region, and this is also South Atlantic region. They asked that why do any tropical cyclones do not occur in the southeast and these Southeast Pacific and South Atlantic region. The reason for that is that you do not see any landmass here, right? Since there is no landmass, I talked about continentality, because landmass gets heated up more quickly than the water. If you have a water body which is surrounded by landmass, definitely that water body would also get heated up more quickly. If there is not going to be any landmass, a water body would be heating up at a lesser rate compared to a water body which is more continental in nature or which is surrounded by land masses. Since there are no landmass which is available or this is present in this region of the world, there is no rise in the temperature. Thus 27 degrees Celsius is not achieved. The sea surface temperature remains to be low, and thus there is no formation of tropical cyclones. Clear? Now the options which had been given in the examination were the sea surface temperature are low, and the other one was there is no landmass which is present here, right? Plus there were two other frivolous options which were given, which one could have eliminated easily. These were the two options which one finally came down to. Now as per us, the answer is the absence of landmass. The reason for that is because that is a condition which is specific to this particular region of the world, right? There is no doubt that sea surface temperature low is the reason or the cause, but sea surface temperature is low in many other parts of the world also. But when we talk about this particular region, that main cause is the absence of landmass and therefore lesser sea surface temperature, and because of that we do not witness any tropical cyclones, right? Similarly, why do we not witness any of the tropical cyclones, or why do we witness more of tropical cyclones in the Bay of Bengal when compared to the Arabian Sea? Again, the reason is similar. The Bay of Bengal is more continental in nature as a water body than the Arabian Sea, which is a more open-ended body. आप अगर इंडिया और अफ्रीका के मैप के हिसाब से देखोगे, you will see that, okay, I think perhaps I'll show you the world map only. Okay, so see this. The Bay of Bengal is a more continental body compared to the Indian Ocean, and therefore the temperature which is witnessed in the Bay of Bengal is significantly more than compared to the Arabian Sea, and that is one of the main reasons because of which we witness tropical cyclones only in the Bay of Bengal, or comparatively more tropical cyclones in Bay of Bengal than the Arabian Sea. Another point to note is that tropical cyclones, since they originate in the tropical areas, they move under the influence of the trade winds. Yes, therefore they move from which direction to which direction? From east to west, not necessarily northeast, but let's say east to west, right? They move from the east to west directions under the influence of the trade winds, and therefore the eastern coast of India is more susceptible to tropical cyclones than the western coast of India, because tropical cyclones move from east to west. Clear? Right? So this is about the tropical cyclones. Now we are just waiting for the assignment sheets to come in, so that we can have the class assignment and people could attempt those questions, and then we could discuss them. In a way, that would be more or less a recap of whatever we have studied today, so that we not only consolidate it but also add on to other knowledge which might have gone missing in the lecture. Right? In the meanwhile, if you people want to take a break or go out for having water, you can. Yes.
Bay of Bengal area, you said there is no tropical cyclone. So there should be more tropical cyclone because there is no landmass.
There is? Where is?
Bay of Bengal.
Bay of Bengal में तो ज़्यादा है ना tropical cyclones.
Because there is no landmass.
There is landmass. भाई ऐसे मत करो. Bay of Bengal देख रहे हो, continental है, ज़्यादा landmass ज़्यादा present है, therefore heating up of the land होता है, therefore temperature higher होता है, इसलिए tropical cyclone होता है. Eastern जो वेस्टर्न कोस्ट ऑफ इंडिया है, अरेबियन सी जो है, वहां पर लैंड मास कम है, वो एनक्लोज नहीं है ना. बे ऑफ बंगाल आपने देखा एनक्लोज्ड बॉडी है एक, राइट. देयरफॉर टेम्परेचर ऑफ दिस बॉडी सिग्निफिकेंटली हायर देन द अरेबियन सी एंड राइट. ओके. Jet stream, no, tomorrow next 3 classes are going to be for history. Yeah, next I think 16, 17, 18 classes are for history, and then the next class whenever geography happens, we'll talk about jet streams, and then we'll talk about some of the other phenomena, temperate cyclones, and then we'll also talk about air masses. We will not cover very extensively because it's more for the point of view of optional and a little bit from the point of view of mains. Cloud formation we'll explain. Precipitation वगैरह का जब चैप्टर करेंगे तब करेंगे. हाँ. No, this is so we'll give you take home assignments. You attempt them on your own, and in case if you have any doubts, we'll discuss them in the class. हाँ.
Next respective class.
हाँ. Yes.
So can you please explain again that how this the presence of land mass affect the cyclone?
Okay. See, the thing is, यार वीडियो नहीं है, मतलब आप खुद सोच के देखो एक बात. देखो, as I told that land mass gets heated up more quickly than water. Yes. अगर एक लैंड मास के पास में एक वाटर बॉडी होगी, because of the land mass getting heated up significantly, it would have effect on the nearby water body also, right? Because land mass heat हो रहा है तो उसके पास वाला water body भी heat होगा, उसकी वजह से convection currents होंगे, right? अगर सिर्फ water body present होगी, land mass नहीं होगा, so we already talked that how water body anyways gets heated up very slowly.
But that eventually going to heat up, no?
It is going to heat up, but it never heats up to a certain extent as it is accentuated because of the presence of a landmass. See, the thing is that it will get heated up, but by the time, as I said, when did I say that tropical cyclones अक्टूबर में ही क्यों अकर होते हैं? उसका रीजन ये है, it takes time to heat up, but वो process of heating up इसलिए accentuate होता है क्योंकि land mass पास में होता है. Body heat up होती है पर 27 डिग्री सेल्सियस नहीं क्रॉस कर पाती है because of the absence of land mass.
I'm asking this question in the context of the you told the question that was in prelims.
हाँ.
The cyclones occur in the Pacific region.
They do not occur in the Southeast Pacific and the South Atlantic region.
But I think if I'm not wrong, the
यार देखो, ऐसा नहीं है कि चाय की मतलब पानी रख दिया और वो गर्म हो रहा है और होता रहेगा. ऐसे अगर उस तरीके से गर्म हो रहा होता तो फिर मतलब 50 साल बाद मतलब पानी गर्म होके फिर साइक्लोन हो जाता है एक बार. ऐसा नहीं होता ना. What tends to happen is that is a there is a seasonal cycle which is there. So 6 महीने ही होते हैं वाटर बॉडी को गर्म होने के लिए. ठीक है, उसके बाद तो फिर विंटर्स आ जाएंगे, राइट. इंसिडेंस ऑफ इंसोलेशन दूसरी साइड शिफ्ट कर जाएगा, राइट. सो विंटर्स वुड बी एक्सपीरियंस, तो वैसे ही टेम्परेचर कंपैरेटिवली कम होगा. So it has only 6 months, and in those 6 months the water body does not get heated up enough because there is no landmass which is present nearby, because landmass gets heated up very quickly, and therefore this heat through convection gets transferred to the nearby water bodies which get heated up much more quickly than the bodies where there is no landmass. Clear?
सर आपने वो बताया, वो बताओ ना, वो बे ऑफ बंगाल में ज़्यादा होता है और
बे ऑफ बंगाल में ज़्यादा. हाँ, बे ऑफ बंगाल में हीटिंग अप ऑफ दी, अगर आप देखो, आप कॉन्टिनेंटलिटी मैप देखो यार आप.
आपने ईस्ट और वेस्ट बताया वो.
Okay, east or west? So see, the thing is that why does the east coast of India suffer maximum destructions from tropical cyclones and not the west coast of India? Because tropical cyclones move from east to west under the influence of trade winds. Why? Because they occur in the tropical areas. Therefore, they move under the influence of trade winds. Therefore, so if this is the coast of India, they move from east to west. अगर यहाँ पे occur करेंगे तो यहाँ जाएंगे ना. So therefore the western coast of India does not experiences as much destruction because of tropical cyclones as the eastern coast of India does. गुजरात और महाराष्ट्र के कुछ रीजन्स में ट्रॉपिकल साइक्लोन्स का इफेक्ट हर साल देखा जाता है, but that is not as significant as what is witnessed on the eastern coast of India. ठीक है? Any other? Yes. Which, where is it written? Impact on humans. Okay. The cyclones which cross 20-degree north latitude generally recurve and they are more destructive. Okay. So see, the reason for that particular phenomenon is because of the increase in the Coriolis force beyond 20-degree north, or or beyond 20-degree south, right? So beyond 20-degree north as they move, 20 डिग्री साउथ में इसलिए एप्लीकेबल नहीं होता बिकॉज 20 डिग्री साउथ के अंदर फिर वो लैंड मास गायब होना शुरू हो जाता है, राइट? 20 डिग्री नॉर्थ के अंदर एज दे मूव देयर इज ग्रेटर प्रेजेंस ऑफ कोरियोलिस फोर्स विच इज देयर, विच अगेन लीड्स टू द रिकर्विंग ऑफ द ट्रॉपिकल साइक्लोन एंड विच लीड्स टू ग्रेटर डिस्ट्रक्शन इन दीज एरियाज. क्लियर?
रिकर्विंग से क्या कह रहे हैं? और वो
हाँ, रिकर्विंग, कर्विंग थी ऑलरेडी, दैट हैड गॉट डिसिपेटेड because as it was moving, but what tends to happen is recurving tends to happen because of greater presence of the Coriolis force and the winds tend to recurve again, ones which had straightened out or the ones which had lost their impact. ठीक है?
So why not in the south? Again the landmass problem?
Yes, again same. Yes, same. वहाँ पे तो वैसे ही लैंड, आप अगर देखोगे ट्रॉपिकल साइक्लोन्स जो हैं वो सदर्न हेमिस्फीयर के अंदर लार्जली अकर करते ही नहीं है, बिकॉज आप मैप ऑफ द वर्ल्ड ही देखोगे. सो दिस इज वेयर माई फिंगर इज 0 डिग्री एक लैटिट्यूड. लुक एट द डिफरेंस, लैंड मास इन द नॉर्थ एंड लैंड मास इन द साउथ, राइट? फॉर एग्जाम्पल विच आई थिंक फ्रिजिड जोन, टॉरिड जोन, टेम्परेट जोन पढ़ाने की ज़रूरत नहीं थी, या फिर मेरे को लगता है कि ये एग्जैक्टली बताने की ज़रूरत नहीं थी कि भाई इंसोलेशन यहाँ पे ज़्यादा होता है कम होता है, उस पर मैंने बहुत ज़्यादा टाइम स्पेंड किया इनिशियली, बट दैट वाज टू जस्ट गेट द एंटायर क्लास ऑन टू द सेम लेवल, राइट? सो व्हाट आई थिंक ही इज मेकिंग वैलिड पॉइंट इन दैट सेंस. इज देयर एनीवन एल्स हु अग्रीज, हाउ मेनी पीपल अग्री विद हिम दैट दिस शुड बी एन advanced concept batch? Okay, so I see that. Okay, and how many do not agree with him? I see some people are not raising hand at all. Okay, so I think it's a 50-50 kind of a thing is what I realize, but I think perhaps then what we would do for perhaps next 1 or 2 more classes is that we will keep focusing on some of the basic concepts also, but maybe give lesser time to that and give more time to the conceptual issues. Say, again, Bay of Bengal में tropical cyclones ज़्यादा होते हैं, इसमें नहीं होते हैं, and those kind of things which can be asked in the examination, some which are very sticky conceptual issues. Say for example, the structure of a tropical cyclone and all these, ये सारे थोड़े sticky issues हैं which are difficult to understand on your own, right? So that is one thing. Okay, sorry. So that is one thing, but also one thing which I would suggest to people, those who are looking at it कि हमें थोड़ा सा यहाँ पे बेसिक चीज़ें भी पढ़ाई जा सकें. From next class we will be uploading the material for the next class in advance on the online platform, so that you can get access to it. You can give it a basic reading and glance through some of the material and come into the class being a little prepared, so that I then need not tell each and every one that why this is a torrid zone and temperate zone and frigid zone, because that is, in my opinion, he's right in a way that the prelims is perhaps just like 3 months or 4 months away from now, and we cannot afford to spend a lot of time on such basic concepts, otherwise we might just miss the train in that way, right? So therefore, people, those who want some of the basics to be covered, we will ensure that some of the basics are covered in the class, because I'm sure that even the ones who are seeking advanced concepts, they might also have some issues in some basic areas. But at the same time, please do ensure that you read before you come to the class. This is for all those who are attending the classes, irrespective of whether you are looking at it as an advanced batch or a basic batch. One is that, right? Second thing which I also wanted to know from you is that Okay, no, yeah, that's all about it. Second thing which I wanted to tell you was that tomorrow the class is going to be on modern Indian history, and Jaspreet is going to take it, and he is going to start from the 1750s and the early 18th century in terms of how the British East India Company came here and then how their expansion happened and so on and so forth. So he's going to deal with the modern history part for the next 3 classes, right? So that is going to be the broader approach. As far as geography is concerned, the next class मैं पहले से ही बता देता हूँ topics so that आप लोग भी थोड़ा पढ़ के आ जाना. Jet streams will be covered. Temperate cyclones is a little bit technical in nature, so even if you do not know about it, it's okay. But if possible, please do read about air masses. What are air masses? And what is the significance of air masses? तो आप एक बार वो पढ़ के आ जाना. यहाँ पे ही जो टेम्परेट साइक्लोन और फ्रंटल फॉर्मेशन और फ्रंटल प्रेसिपिटेशन वगैरह हम यहाँ पे डील कर लेंगे. जेट स्ट्रीम्स हो गया. देन अनदर टॉपिक इज कन्वेक्शन इन द टाइप्स ऑफ फॉर्म्स ऑफ प्रेसिपिटेशन एंड द टाइप्स ऑफ प्रेसिपिटेशन. And forms or types के अंदर we will be also covering clouds and what are the different types of clouds and so on and so forth. तो वो सब area भी cover किया जाएगा. Plus in the next class, since we will be covering jet streams, I will also deal in detail with the topic of monsoons. Monsoon is a very technical topic, and I can bet it that 90% of the teachers, those who teach out there in Rajendra Nagar or elsewhere, do not understand the mechanism of monsoon themselves, and therefore end up confusing the students. Therefore, please do make sure that you attend that portion very attentively. That's in a way, once you sit through those 20 minutes of understanding what monsoon is, I will make sure that you understand the entire phenomenon of monsoon crystal clear. एकदम पूरी तरह से it will be very crystal clear to you that what is monsoon, what is El Nino, what is ENSO, what is southern oscillation and everything. That all would be covered, right? Plus apart from that, there are a few other miscellaneous topics which are there in the topic of climate. So we will be we'll be touching upon some of the climatic regions of the world also in next class. I'll just mildly touch upon them because I would also want to cover the physical geography. Then only would I want to move into the this thing. And plus, I think there was certain basic distinction between climate and weather and this and that. So please read your notes. Please refer to Goching Leong and your physical geography की जो NCERT है या जो total geography की किताब आती है ICSE की. Total geography is something which I recommend more over the NCERT. But NCERT again has its own benefits, and total geography की किताब भी जो है I am not having it right now, but it is also not much, इससे ज़्यादा मोटी नहीं है वो भी, इतनी ही thick है वो भी, so you can get hold of that, right? So that is as far as the next class is concerned. Now let's just quickly discuss this particular assignment. Okay, so I am skipping the first question. Remind me in the next class that we have to discuss this question. First, let's talk about the second question. So the second question says that you have to mark the incorrect statement, right? And how many of you marked A as the option? Only that many. Okay. How many of you marked B? Okay, surprising. How many of you marked C? Okay. How many of you marked D? Okay, right. So the correct answer is A, and 1 and 3 are wrong. Now how? Right. So the Coriolis force is maximum at equator and goes on decreasing to 0 at the poles. Obviously, this is a wrong option. I think almost all of you would have marked it incorrect. Vignesh, how did you mark this correct? The incorrect one. Oh, okay, you okay. Okay, right. Anyways, right. Then the third option is also incorrect. It says that cyclonic systems do not develop in equatorial region because of heavy Coriolis force. They do not develop in equatorial regions because of absence of the Coriolis force, right? And then the second option is obviously correct. It says that Coriolis force compels the surface wind to spiral towards the low pressure systems, right? So the answer is that 1 and 3 are wrong, and the answer is A. Anyone has any doubt over this? Simple. Moving on to the next question. Which of the following statements are true? The Earth's surface receives energy in short wavelengths more than in the long wavelengths. True. Then the energy emitted by the sun is known as insolation. No. The energy which is received by the earth is known as insolation, and not the energy which is emitted by the sun. That is wrong. And then the energy received by the earth is maximum when the earth is at perihelion. Again a simple question, 1 and 3. Therefore option mark answer was C. Now question number 4th. All the options are correct. Rotation of earth on its axis, right? Revolution of earth around the sun, that is also responsible for the amount and intensity of the insolation received, because कुछ part of the जो surface है that receives एपीहिलियन और पेरिहिलियन का कॉन्सेप्ट वहीं से आता है. Angle of inclination of sun rays, obviously this is important because some parts of the earth receive more insolation and some parts receive less. Length of the day, we talked about it. Transparency of the atmosphere, also we talked about it. And inclination of earth's axis. If earth would have been not inclined and horizontal, then obviously all the parts of the earth would have been receiving the same amount of insolation per unit area, if not the same amount of insolation, right? So in that case, the axis of the inclination of the earth on its axis also determines. Also the shape of the earth. This is also one option which you can add. Shape of the earth. If earth would have not been a sphere and would have been a cube or say whatever, right? Then all the parts of the earth would have received the same amount of insolation per unit area. Get it? How? Nahi? Arey bhai. If the earth would have not have been tilted, that is. If it would have been tilted, then it would have been a completely different matter. But if in case this would have been a cube, say, right? So the distance, the insolation received on would have been the same, right, on all the parts of the earth. So the spherical shape of the earth is also one of the reasons for the difference in the insolation which is received by different parts of the earth. Okay, fine. Now moving on to question number 5. I think this is the simplest question. It talks about trade winds and westerly winds are surface winds that originate from the tropical high belt. Right? Clear? There is no doubt on this? Okay. Question number 6. Westerlies are referred as roaring 40s, furious 50s and stormy 60s in southern hemisphere, but such westerlies are not present in the northern hemisphere. Why? Exactly. So southern hemisphere has large extent of ocean from 40 to 60 as compared to the northern hemisphere. And is it because that the Coriolis force is much stronger in the southern hemisphere? No, right? Okay. The effect of the Coriolis force is stronger, but the Coriolis force itself is not stronger, right? Okay. Then moving on to question number 7. Which of the following statements are correct regarding the tropical cyclones in India? Tropical cyclones are steered by easterly jet streams into India. Easterly jet streams, no, right? It's the easterly trade winds, right? Paths of tropical cyclones are mainly determined by the position of ITCZ. Yes or no? हाँ? ये तुम्हारे तो यार गलत ना ये दिया हुआ है. Anyways, yes, they are determined by the position of the ITCZ. The tracks of the tropical cyclones are the areas of highest rainfall in India. Yes, right? So the options are 2 and 3. The explanation which will be provided to you will mention 1, 2 and 3. It's not 1, 2 and 3. It is 2 and 3. Okay, fine. Tropical cyclones derives its energy from evaporation of ocean water. Anyone has any doubt on this? They do not derive their energy from Coriolis force. Coriolis force just, yes. हाँ. So it says that the paths of the tropical cyclones are mainly determined by the position of the ITCZ. See, what it means to say is that it is the ITCZ which determines the track of the tropical cyclones. Why? Because if the during the summer months the ITCZ has shifted by certain degree, and that causes the heating up of the apparent shift of the sun, therefore causes the heating of the water bodies. Since the ITCZ shifts, you have to also understand, because of the ITCZ the more heating up takes place, and therefore the development of the tropical cyclones, and thus determining the track of the tropical cyclones. How would it influence the path of the Okay, so not fine. So I talked about the origin. It influences the path because the trade winds blow as the ITCZ position is, right? So that is how the track or the path of the tropical cyclones is determined by the position of the ITCZ. See, जो आपकी trade winds हैं, they blow till the ITCZ, right? So the track of the tropical cyclones in a way is decided because of the position of the ITCZ. Clear? Clear, or you want me to explain it further? Okay, see, what I am trying to say is that ITCZ जो है आपकी ट्रेड विंड्स कहाँ से कहाँ तक ब्लो करती हैं? सब ट्रॉपिकल हाई से आपका ITCZ तक ब्लो करता है. अगर आपका ITCZ का कहीं पे भी लोकेशन चेंज होगा, दैट मीन्स आपका ट्रेड विंड्स का भी जो लोकेशन है वो भी चेंज होगा. ट्रेड विंड्स कहाँ से कहाँ तक ब्लो कर रहा है. एंड सिंस ट्रॉपिकल साइक्लोन्स आर गाइडेड बाय द ट्रेड विंड्स, that means that tropical cyclones would be guided by the position of the tropical ITCZ indirectly.
जब अक्टूबर नवंबर में
हाँ,
ITCZ नीचे मूव करता
ITCZ नीचे, exactly.
है, उस टाइम पे वेस्टर्लीज हमारी जो होगी इस डायरेक्शन में होगी.
Westerlies, east.
ट्रेड विंड तो सर इस डायरेक्शन में होगी भाई, नॉर्थ ईस्ट टू साउथ.
हाँ,
ठीक है ना.
right.
तुम्हारा ITCZ तो नीचे आ चुका होगा.
हाँ.
उस टाइम में
So that exactly, that is also one of the reasons because of which the ITCs, the tropical cyclones do not occur during the months of your June, July, August, etc. Because the ITCZ is covering a huge part of the country. There is a shift in the ITCZ. You got it?
लेकिन पाथ कैसे इन्फ्लुएंस करेगी तो पाथ कैसे?
Yeah, path direction. The path in the sense that what is the what do you mean by a path? The distance which traveled by the tropical cyclones is also the path. So do not necessarily look at it as a direction. It's not the direction which, get it? It's not the direction, it's the path. That this is the path it is going to travel. Clear? Okay, fine. Then moving on to question. Okay, yeah.
Question number 8, why it's not because of the Coriolis force, the tropical cyclone?
Bhai, tropical cyclone exists because of the presence of Coriolis force, but it does not derive its energy from the Coriolis force. It derives its energy from the latent heat of condensation which I talked about, and that is nothing but evaporation of the water, right? It's a heat engine. स्टीम इंजन देखा है आपने, हीट इंजन देखा है, वैसा ही हीट इंजन होता है एक ट्रॉपिकल साइक्लोन, जिसके अंदर आपको हीट मिलती है, लैटेंट हीट ऑफ कंडेंसेशन, एंड देन इट ऑपरेट्स, द एंटायर सिस्टम ऑपरेट्स. ओके, क्वेश्चन नंबर 9, व्हिच ऑफ द फॉलोइंग आर द इनिशियल कंडीशंस फॉर द ट्रॉपिकल साइक्लोन टू अकर? वार्म एंड ड्राई एयर? यस, नो? यस? स्टेबल ट्रोपोस्फियर रीजन? Strong Coriolis force? How did someone say warm and dry air? Warm and dry air में तो tropical cyclone exist ही नहीं कर सकता. You need moisture. If you do not have supply of moisture, the tropical cyclone will cease to exist, and that's why it does not exist on the land. Right? Okay. Question number 10th.
So the answer is 3.
Yeah, the answer is only 3. You will get the solutions. Which of the following are the characteristics of tropical cyclones when compared to the extratropical cyclones? They cover large area? No. I told that the larger area is covered by temperate cyclones. They can originate over land or sea? No. This is true of the temperate cyclones. They can originate over both land and sea, but not of the tropical cyclones. They originate over only sea. They have clear frontal system? No, they do not have a clear frontal system. In fact, the frontal system exists only in the case of temperate cyclones where you have a cold front and a warm front, etc. Right? So therefore none of the above. Question number 11th. The combination of which three forces affects the horizontal winds near the surface? Easy. Right? No centripetal force. Right? Question number 12th. Which of the following statement is correct regarding the Coriolis force? Which one? Due to the Coriolis force, winds are deflected in right side in the northern hemisphere? Right. Wind deflection due to Coriolis force is maximum at equator? No. Due to Coriolis force, wind speed increases near the equator? No. Right? Okay. Reasons for polar high are extreme low temperature keeps high pressure? Yes. Descending of polar night jet over the pole increases the pressure. This is also one of the reasons, right? The reason why I didn't touch this upon this is because it's a concept related to jet streams. We'll touch upon it, but this is one of the reasons which reinforces the polar high. The polar high gets even more stronger because of the presence of polar night jet. Okay, fine. Both the answer, both 1 and 2. Question number 14th. Sorry. अच्छा, not is are not correct. Sorry, neither 1 and 2. Sorry, मैंने देखा नहीं था वो की में 13th. Yes, okay. 14th. 14th. It says consider the following statements with regard to the naming of the tropical cyclones. Okay. There are 5 tropical cyclone regional bodies for naming of cyclones. Yes. Okay. I'll just read that particular thing to you. And then every regional committee determines a pre-designated list of hurricane names for 6 years separately at its annual session. This is also correct. And these hurricanes are named after a particular person? No, they are not named after a particular person. It's generally given to name of a child, okay, either a girl child or a boy child, right? And it moves from the east to west. So I'll just read it out as it's been mentioned in your explanation. It says that the tropical cyclones are named neither after any particular person nor with any preference in alphabetical sequence. You would have heard of Hurricane Katrina and Hudhud and Neelam and all these, right? जो भी इतने सारे सुने होंगे. Now the tropical cyclones names selected are those that are familiar to the people in each region. One is that. तभी नीलम जब नाम रखा गया था तो नीलम is the name of a girl child in Pakistan. Okay. Obviously, the main purpose of naming a tropical cyclone are familiar is basically for people to easily understand and remember the tropical cyclone or the hurricane in a region. Thus, to facilitate tropical cyclone or hurricane disaster risk awareness, preparedness, management, and reduction. Right? And every year it moves from the east to the west. Every year when a tropical cyclone is about to occur, a country within that particular region or that particular region for naming the cyclones is given an opportunity to name it after a child in its country, whether a female or a male child. And it goes in an alternate sequence, a male child, then a female child, and so on and so forth. Okay? Okay. Now, moving on. So, the answer to this is B, 1 and 2. Okay. Then, question number 15. What are benefits of westerly disturbances to India? Both of them are true. Both of them. No. Okay. So okay. So fine. So fine. Wait. It destroys the rabi crop. When there is excess of rainfall which happens due to the western disturbances. Otherwise, there is this minimal moisture which is required during the winter season, during the sowing period, where the western disturbances help the cultivation of the rabi crops, right? So it has both the positives and the negatives. That's what I was talking about. Perhaps I missed talking about it because there were too many things going in my mind. But it leads to it is beneficial for rabi crops if the rainfall is not in excess. But at the same time, you would hear constantly जब western disturbances से बहुत सारी फसल जब बर्बाद हो जाती है, so news के अंदर they say that because of the तूफान or because of the western disturbances, the फसल has got destroyed and therefore there is going to be a rise in the prices of the crops, so especially wheat, etc. Right? Okay. Then question number 16th we are going to skip. Question number 17th. Water vapor reflects a significant portion of the incoming shortwave solar radiation. No, it does not reflect the significant portion. Water vapor prevents outgoing terrestrial radiation, thus creates a greenhouse effect. Yes, it does. It acts as a greenhouse gas. In fact, water vapor has one of the very high effects of greenhouse compared to the other gases such as carbon dioxide, etc. Water vapor is, I am not sure that how many times more powerful it is. I can't remember the statistics, but it is way more powerful than carbon dioxide as far as greenhouse effect is concerned. Yes, naturally it is the most abundant greenhouse gas or greenhouse material which is available in our atmosphere. Okay, move. Yes. 17th का सिग्निफिकेंट पोर्शन नहीं रिफ्लेक्ट करता. सिग्निफिकेंट पोर्शन जो है आपका, देखो 51 के अंदर मैंने जब आपको बताया था, है ना, ठीक है. Okay. With reference to hot desert, consider the following statements. Okay, let's understand this first. Now, see, the thing is that the hot deserts of the world are generally located in the subtropical regions on the western margin of the continents. There are many reasons for that. There was a question also which was asked in 2013 or 14 in UPSC on this. Mains. What is the reason? I think 2013 mein pucha tha. The reason for that is, first of all, in the subtropical western regions of the world or western parts of the continents, you have presence of which winds? Presence of winds. Winds कौन सी होती हैं बताओ? Easterly trade winds. These winds would be blowing from the east to west and therefore would be bereft of any moisture, would not be having any moisture or would be dry in nature, and thus they would not lead to any rainfall. Right? One is this reason. The second is that cold currents is the third most important. The second most important reason is that these regions of subtropical highs, 30° north, 30° south, are also regions which have huge subsidence of air, right? These are zones of convergence. Therefore, stable conditions exist. Because of stable conditions and because of the convergence of air, there is no upliftment of air which takes place. Thus, stable conditions and thus no rainfall, and thus these regions are bereft of any convectional bereft of any precipitation. Right? Got it? समझ में आ गया सबको? नहीं आया? किसको नहीं आया? हाथ खड़ा करो. बोल दो यार. Do not be shy. Okay. See, we talked about the subtropical high pressure belt. Yes. What was subtropical high pressure belts? We know that these belts, remember this diagram, 0, 30, okay? This, wind is descending here. Similarly, this, wind is descending here. Now wind is descending here, that these are regions of high pressure. Right, these are regions of convergence. Right, now since these are regions of divergence, right? These are regions of, yes, convergence, right? So now you have high winds converging over onto these areas. I'm really sorry, I keep confusing 30 with 60. These are regions of high pressure. You have converging winds out here. You have subsiding winds out here. Now, for precipitation to happen, एक बहुत basic चीज जो आपको पता होनी चाहिए, that air has to rise, right? Then it reaches its saturation level and then it sheds moisture. अगर air descend कर रही होगी, that means that is leading to more stability, and thus it will not shed any moisture. And thus these regions are bereft of any precipitation. Clear? अब समझ में आ गया? अभी भी नहीं समझ में आया? I'll explain it again. There is no. Okay. See, what I am saying is that these are regions of descending air currents. Now, for precipitation to happen, air currents have to ascend. Orographic में आप convectional में या आप even frontal में देखोगे, air has to ascend. वो मैं अगली क्लास में बताऊंगा कि why air has to ascend. There is a very simple physical reason behind it. Because air expands as it keeps going ऊपर, right? And therefore it expands and adds more moisture, and then at one point of time when it cannot add more moisture, it sheds that moisture. As far as the descending winds are concerned, जब wind descend कर रही होगी तो वो contract हो रही होती है, वो ड्राई होती है नेचर के अंदर, and therefore it does not carry any moisture and thus does not lead to any precipitation. Fine. Now the third reason is the presence of cold currents on the western margin of the continents or on the eastern margin of the oceans. We'll talk about it later when we talk about the ocean currents, but for now just remember that the eastern margin of the oceans or the western margins of the continents, both of them are the same thing. ओशियन का ईस्ट और कॉन्टिनेंट का वेस्ट सेम चीज है, ठीक है? सो दीज रीजन्स हैव कोल्ड करंट्स, एंड एज आई सेड अगेन, सिंस देयर आर कोल्ड कंडीशंस व्हिच आर प्रेजेंट देयर, स्टेबल कंडीशंस आर प्रेजेंट देयर, देयर इज नो convection which takes place, there is no ascent of the winds which takes place, and thus it leads to dry stable conditions in these areas. Thus you will see majority deserts of the world, whether it is the Thar desert, the Sahara desert, the Atacama desert, the Californian desert, all of these deserts are majorly located on the western margins of the continents in the subtropical areas near 30° north and south latitude. ईस्टर्न नहीं भाई, वेस्टर्न. यार ये मत करो अभी, मतलब वेस्टर्न, अभी तो मैं समझाया वेस्टर्न पार्ट्स ऑफ द कॉन्टिनेंट, ट्रेड विंड्स आर ब्लोइंग लाइक दिस. दिस इज इंडिया, this is our western continent, this is our western coast. Winds are blowing like this, they are offshore winds, they do not have any moisture, these are trade winds, right? Secondly, there is subsiding of the currents which is taking place here, and then the third is that there is presence of cold currents here. ठीक है? Clear? Everyone is clear about this? Okay, fine. So the question is with reference to hot desert, consider the following statements. They are found in high pressure belts. Huh? I mean, that okay. Okay, warm ocean currents flow along the coast of hot deserts? No. Normally rainfall occurs in these regions is convectional? Yes. The only rainfall which occurs in the hot deserts of the world is convectional in nature, which happens because there is huge amount of heat and heating of the water bodies and otherwise which takes place in these areas, and because of which the warm air rises, it gets cooled up and then it sheds its moisture, right? So therefore the answer to this will be 1, 1 and 3. Okay? So 18th, the answer is 1 and 3, B option. Now 19th, consider the following statement comparing cyclone and anticyclone. When the cyclone approaches, there is a rise in barometric reading while an anticyclone causes barometric reading to fall. No or yes?
Low pressure barometer.
How many say yes or how many say no? I'm sorry, you are wrong. When a cyclone approaches, there is a rise in the barometric reading. Right, there is. I'll talk about it next time. मैं इसको explain कर दूंगा इस चीज को. And while an anticyclone causes barometric reading tends to fall, just this thing. This is wrong. This statement is wrong. ठीक है. Then the isobars are closer in a cyclone. What happens when a cyclone basically approaches is that there is a fall in the barometric reading in reality, and when the cyclone, when the anticyclone approaches, there is a rise in the barometric reading. Opposite from what has been given here.
Sir, one second. Can you please repeat?
This statement is incorrect. First. That is this is incorrect. This is incorrect. This no, I meant okay. I thought that you people are saying that this is okay. Sorry. So this statement is incorrect, right? Okay. Then isobars are closer in a cyclone when compared to that in an anticyclone. Yes, the isobars are very close in the in a cyclone when compared to in the anticyclone, and that is precisely because of which that explains in a way why you have high velocity of winds in a cyclone, because the isobars are very close. Isobars are those lines which connect those points which have same pressure. So isobars are very close. That is, इस पॉइंट का A पॉइंट का आइसोबार ये होगा, B पॉइंट का आइसोबार ये होगा, C पॉइंट का ये होगा. जितनी ज्यादा क्लोज ये आइसोबार एक दूसरे के होंगे उतना ज्यादा प्रेशर ग्रेडियंट कम हो ज्यादा होगा, और उसका मतलब है कि उतनी ही ज्यादा वेलोसिटी होगी, स्पीड वेलोसिटी या स्पीड होगी ट्रॉपिकल साइक्लोन की. ठीक है. नाउ द थर्ड ऑप्शन इज आल्सो रॉन्ग. इट सेज दैट इन द नॉर्दर्न हेमिस्फीयर साइक्लोनिक सर्कुलेशन इज क्लॉकवाइज व्हाइल एंटी साइक्लोनिक सर्कुलेशन इज well anticyclonic circulation is clockwise in the southern hemisphere, rather it's the opposite. ठीक है. हाँ.
The pressure gradient will be less. So how could
Pressure gradient would be more.
if they're close, then the pressure gradient will be less.
No, the pressure gradient would be more, because there is change in pressure over a very small. Pressure is changing very quickly from one place to another. So therefore the pressure gradient is more. Isobars, see, this is one place which has equal pressure. This is one place which has equal pressure. This is one place which is equal. These.
Isobars when two areas have same pressure.
Yes.
So all these areas have same pressure.
No, all these areas have not same pressure. This line would have. This is an isobar. This is an isobar. This is an isobar, right? And when they are closer, the change in the pressure would be more, right? Okay. Fine. Now let's talk about question number 20. Consider the following statements about the jet stream. Okay, we don't need to talk about this abhi. Consider the following statements regarding tropical cyclone. East coast of India is more prone to tropical cyclones compared to west coast of India. Yes, we have talked about it extensively. Tropical cyclones are larger in size as compared to tropical cyclones. No, temperate cyclones are much larger in size when compared to the tropical cyclones. I told you about this already. Then move on to question number 23. Which one of the following statements is correct? The Earth's rotation creates the Coriolis effect. Yes. The Coriolis force deflects wind motion, making air spiral around cyclones and anticyclones. Yes. Cyclones are centers of low pressure and divergence. No, they are centers of low pressure but convergence. Anticyclones are centers of high pressure and convergence. No, they are centers of high pressure but divergence. Right. So therefore option number 1 and 2 are correct, and A is the answer. Then consider the following statement about doldrums. It is a belt of low pressure between the westerlies and the trade winds. No, it is a belt of low pressure which exists between the trade winds near the equators. It is an area of variable winds and calm conditions. Yes. It is an area of convergence and strong upward movement of air. Yes. It is an equatorial belt of low atmospheric pressure. Yes. Right? Anyone has any doubt on this? Okay. Doubt?
Can you discuss point number 1?
Point number 1, it is a belt of low pressure between the westerlies and the trade winds. Westerlies और trade winds का कहाँ relation है बताओ मुझे. This is 30 डिग्री और 60 डिग्री के बीच में वेस्टर्लीज लाई करती हैं और ट्रेड विंड्स यहाँ लाई करती हैं, तो यहाँ पे थोड़ी ना है डोल्ड्रम्स. डोल्ड्रम्स तो यहाँ है. So it's between the trade winds, right? Clear? Yes. Doubt? Okay.
It's an area of convergence and strong upward movement of air.
हाँ, it's an area of it's an area of convergence. So it's an area of convergence, but winds do not converge. Winds do not converge, but it's an area of convergence and strong upward movement of the air. That's I told you, right? कि doldrums के अंदर winds converge. Winds do not exactly converge; they are converging. But before that, before they finally converge, there is an upward movement of the winds which takes place. This statement is right. ठीक है? Okay. I mean, I can understand that you perhaps would have got confused with the area of convergence, but area of convergence and strong upward movement of the air, that's fine. ठीक है? Just maybe a little wording problem in that. ठीक है? Now, consider the following statements about Chinook, a local wind. Wind Chinook is experienced on the windward side of the mountains in North America. Windward or leeward? Leeward. Chinook wind is responsible for snowfall in Rockies. No, I told you that they are snow eater and not responsible for snowfall. The wind helps the growth of fruits and crops in North America. Yes, it does, because it takes away the snow and therefore clears the Californian plains of the snow, and therefore could be used for cultivation for fruits and crops in North America. Right? This is Chinook. Okay. Which of the following conditions given below favor the formation and intensification of tropical cyclone? इसका क्या? Who has marked A? Who has marked C? Okay. So the answer to this is C, and the options are 2, 4, and 5. So you need to have presence of Coriolis force, you need to have high sea surface temperature and pre-existing low level cyclonic condition. These are the 3 conditions which are there. Moderate to strong wind above the surface. This is a result of the cyclones and not the conditions which lead to the formation of the cyclones. Be clear about it. Then even option number 3, upper convergence above the sea level system. Well, again, there is a presence of an anticyclonic system which is there, but that is an area of divergence and not an area of convergence, right? So this is as far as 26th question is concerned. Clear? किसी को doubt? बोल दो. Do not be, yeah. Third, okay. So it says that there is a zone of upper convergence above the sea level system. So that means I told you that in a tropical cyclone there is an anticyclone which exists at the top, right? So that anticyclone is a zone of divergence and not a zone of convergence. There is an upper zone of divergence above the sea level system which is required as a precondition for the cyclone. ठीक है? Yeah, one of the preconditions. So I'll tell you what, I did not touch upon that deliberately. मैंने 3 ही conditions बताई थी, चौथी मैंने जानबूझ के नहीं बताई, because फिर मेरे को नहीं उसके अंदर पढ़ना था कि वो एंटी साइक्लोन एंड ये कैसे होता है and all that, because again it's not, even I do not understand that, and I put up my hand. I really do not know how does that happen. All I know is that there is presence of an anti-cyclone right above a cyclone, right? In fact, आप कभी भी एक चीज़ ये ध्यान रखना, जब भी ग्राउंड के ऊपर साइक्लोनिक कंडीशंस होंगी उसके ऊपर ट्रोपोस्फियर में एंटी साइक्लोनिक कंडीशंस होंगी, और अगर ग्राउंड पे एंटी साइक्लोनिक कंडीशंस होंगी तो उसके अबव ट्रोपोस्फियर में साइक्लोनिक कंडीशंस होंगी. ठीक है? दिस इज दिस थिंग ऑपोजिट होता है. जैसे कि सरफेस विंड्स में भी मैंने बताया था, सरफेस विंड्स अगर आपकी ईस्ट टू वेस्ट ब्लो कर रही है तो आपका जो 30 डिग्री टू 0 डिग्री ब्लो कर रहा है, तो जो अपर एयर विंड्स है वो 0 डिग्री टू 30 डिग्री ब्लो कर रहा होगा. ठीक है? क्लियर? यस. No. Formation, no. There is an upper divergence which is there. Upper air divergence is there. There is no convergence. ठीक है? Sorry? I टॉप ऑफ द आई के ऊपर ही तो एंटी साइक्लोन है, वही एरिया ऑफ डाइवर्जेंस है. See, you remember this? I drawn that, you know, on top of the eye there will be a anticyclone here, right? So this is a zone of divergence. यहाँ पे divergence हो रही है, divergence of winds. वो वहाँ से वो कोई कह रहा था मेरे को कि वो एक वो बना हुआ है उसके अंदर. What does that mean? So that's a zone of divergence. ठीक है? Okay. Now moving on to question number 27. With reference to winter season in India, consider the following. The high pressure center region lying north of the Himalayas, surface winds with dry continental air mass, correct? Trade winds over northwestern India, correct or wrong? Correct. Eastern jet streams wind over the north of Himalayas, wrong. Eastern jet stream or so there is a presence of subtropical westerly jet stream north of Himalayas during the winter season in India and even the south of Himalayas, but there is no easterly jet stream which is there. ठीक है, अभी के लिए सिर्फ इतना समझ लो. नेक्स्ट क्लास में जब मैं पढ़ाऊंगा मॉनसून तो मैं बहुत अच्छे से एक्सप्लेन कर दूंगा कि ईस्टर्ली जेट स्ट्रीम होती है कि नहीं होती है और कहाँ होती है और कहाँ नहीं होती है. ठीक है, फॉर नाउ जस्ट अंडरस्टैंड दैट देयर इज समथिंग कॉल्ड एज सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम्स which is split into two divisions or two branches, one which is north of the Himalayas and the other one which is south of the Himalayas, and there is no easterly jet stream which is there. ठीक है? Okay. Question? Yeah? Yeah, 2 is right. 1, 2 and 3 are right. Trade winds over northwestern India. Okay. 28th. With reference to insolation received by the earth, which one of the following statements is correct? Is incorrect, sorry. Okay. The amount of insolation received depends only on angle of inclination of sun rays and rotation of the earth's axis. Obviously no, this is correct. This is sorry, incorrect, right? Then you have equator receives maximum insolation and polar area receives minimum insolation. Correct or wrong?
इस क्वेश्चन के लिए wrong.
कैसे?
Because they asked incorrect.
No, is the statement correct or not?
Statement is correct.
Okay. What if I tell you this statement is wrong? The question is not lesser or more. The question is equator receives maximum insolation and polar areas receive minimum insolation. This is false. Why? Okay, where do we receive maximum insolation? Tropical regions, because of the absence of clouds, right? So tropical regions are the ones which receive the maximum insolation and not the equatorial regions, right? So therefore this particular option is also wrong. Insolation reaches the earth's surface in short waves and heat is radiated from the earth in long waves. This you all know is right. Generally at the same latitude the insolation is more over the continent than over the oceans. Insolation which is received over the latitudes is more when compared to over the oceans. Yes, this is right. Fine. So therefore, ठीक है ना ये continent मैंने continentality हाँ क्या हाँ
Can you please tell us which statements are right, not with respect to the
which statements are right? 3 and 4 are right.
not with respect to the questions. 3 and 4 statements are
3 and 4 are standalone right. Do not get confused. ठीक है? Answer is B. अरे आंसर इज बी. इनकरेक्ट भाई, स्टेटमेंट करेक्ट मैं बता रहा हूं कौन सी सही. ट्रू स्टेटमेंट, ट्रू स्टेटमेंट इज 3 and 4 and false statements are 1 and 2. Now you can get your answer on your own. D? हाँ B. हाँ. Okay. 29. The horizontal wind circulation near the earth's surface is due to pressure gradient, fractional force and Coriolis force, all three of them. ठीक है. Now moving on to last question. This one is about the cold local winds. Chinook, are they cold local winds? No, they are hot local winds. Right. As far as the Mistrals are concerned, these are the winds which blow from the France to the Mediterranean and these are cold in nature. Then southerly busters are also winds which blow in the Australian continent and they are also cold in nature and they actually cool the areas of Sydney and nearby regions. And as far as Pampero are concerned, these are winds which blow in the pampas of the Argentina and these winds are very strong winds which are also cold in nature. therefore 1, 2 and 3 are the correct answer. Yes.
So in the question number 28,
Yeah.
just dwell upon one thing. Generally, the same matter, like insolation. Insolation is the light received, not the light perceived. They are not retaining it. This insolation, the light is coming onto the landmass and the ocean.
No. Don't think like that. It's basically about the cloud cover and the number of other water vapor and the precipitation. So the amount of water vapor which is present over the this thing, क्या बोलते हैं, the water bodies does not allow the amount of insolation to be received by them to be as high as the land masses. That is the reason. The reason is not the amount of insolation which is received, that is retained, that is temperature. वो temperature पे बात आ जाती है. मैं insolation की बात कर रहा हूँ. Insolation. So I'll tell you the explanation which your model answer gives. It says that maximum insolation is received over subtropical deserts where the cloudiness is least. Equator receives comparatively less insolation than the tropics, and generally the same latitude the insolation is more over the continent than over the oceans. Also it says temperature of an object determines the wavelength of a radiation, so and so forth. वो एक अलग चीज है. So that's not because of the temperature की बात नहीं कर रहे हैं, insolation की बात कर रहे हैं. ठीक है? Fine. Thank you so much. Sorry? 29th में बताओ क्या? It says the horizontal wind circulation near the earth surface is due to. Actually वो question की language गड़बड़ है. It's that the factors which affect the horizontal wind circulation near the earth surface are वो वाला है question. वो question की language गड़बड़ है थोड़ी सी. ठीक है? So do not worry about that.